Hello, good morning everyone. So, hope you are doing well. Am I audible, right?
Yeah, sir, audible.
Yes. So, today we'll first discuss about week one and week two and week three contents. Then, if you have any doubts regarding any week, so you can ask. So, let me share my screen.
So some mock problem need discussion.
Yeah, you can ask if you have any doubt after this. So, we go through week contains the main topic of each week. Then we will discuss your doubt. So this is the first week contents. The first week basically some concept of the DBMS term is introduced, like what is data, what is database, and what is DBMS. So you all know, so data is any raw factor, a raw fact, right? And database is a collection of data, interrelated data in one place. So that is your database, and DBMS is a database management system, is your uh, the system that is efficiently store the data and use you so that we can efficiently retrieve the data using that system. So that is your DBMS system. And we also saw in see in the week one that are what are the drawback of the file system, and whatever's the drawback of the file system, that are advantage of the DBMS. So here we can see the comparison between the file system and the DBMS system. Okay, so let me walk you through this content. So first comparison is scalability with respect to the amount of data. So for the file system, it is very difficult to handle insert or update or the query of records. But in the DBMS system, it is an inbuilt feature is given so that we can handle the large amount of the data. So this is your first point. Okay. So the second point is scalability with respect to the change of structure. Suppose you have defined some structure of the tables, and later stage you want to add or remove some attribute or some columns into the file system. So it is a very difficult to implement in the file system. But it in the DBMS, it is a very easily you can add or remove attribute using SQL queries, right? And in term of the time of execution, for the large amount data, file system will take some second, but in DBMS system it will execute in a few milliseconds. And in term of the persistence, so data processed using the temporary data structure. Okay. So in terms of the persistence, so data processed using the temporary data structure have to be manually updated into your file system. But in the DBMS system, it will automatically uh, updated the value, or that changes, whatever you change, make the change in your database, that is permanent. uh, Regarding of your system failure or hardware failure also. And the in term of the robustness, so ensuring robustness data has been done in the manually, but in the DBMS system there is a backup or the recovery and restoring mechanism. In that, sometimes it is automatically done, and sometimes it is a manual intervention is also required. And for the security, you can see in the file system it is very difficult to implement any security in your user level. we can implement in the OS level in the file system, but in the DBMS system you can grant access to the individual user as you want. So whatever authorization you want to give, so you can define that into the DBMS system. And in terms of the program's productivity for the file system, every time you access the data you have to write some different code, right? Suppose you want to update, for that you have to write some different code. For delete some you have to write the different code. But in the DBMS system it is the inbuilt query is there, so you have to use. And in terms of the arithmetic operation, so in the Python is a lot of using the this file system via Python, you can do the lot of arithmetic computation, but in the DBMS system there is a limit in the arithmetic operation. But and in terms of the cost, so file system is a low cost and DBMS system is a high cost than file system, right? So now we will see the what are the level of abstraction in the database DBMS. So these are three level of abstraction. First one is the physical level abstraction. Second one is the logical level abstraction. Third one is the view level abstraction. So in the physical level abstraction, it is the lowest level of abstraction where we define how we record or stored in the physical levels. Means our secondary memory, right? And in the logical levels, we are defines what data is stored in our database and what are the relation amongst this field. And we also defines the attribute and what are the data type of that attributes. And view we use for the user specific for the security purpose. So what all data are required for that user, so we can only show that data to that user. And also using this also we hide the data type of that attribute. We only uh, provides the data, not the data type. Also in this way we implement the security, right? So here we this is the here one is the view levels and logical levels and the physical levels. So in physical levels and the view levels there is a physical data independence, right? So physical data independence means whatever changes we are doing in this physical level, it should not affect the view level, logical levels and the view levels. So that is the physical data independence. And between the logical levels and the view levels, there is logical data independence. Right. So whatever changes we have done in this logical levels, it should not affect the view level significantly. Right. So
Sir, any example that logical data independence that
yeah, logical data independence. Suppose this is your instructor table, right? Instructor tables have some attribute, right? Instructor ID of integer type, right? And instructor name with a string varchar, and your instructor address of varchar type, and your instructor salary of integer type, right? So in the view, suppose your some clerk is there, right? So you want to view only of instructor ID, instructor name, and instructor address, right? So in the later stage, if you want to add any attribute to this, suppose the instructor department, right? So in this table, instructor table, you can see it should not affect the clerk view, right? Because it's so instructor id, instructor names, and instructor address only. So that is the physical data independence means. So whatever your changes in this instructor tables, that should not affect the view levels. So I hope it is clear.
So can you please explain once again? Sorry,
So
I joined just now.
yeah, sure. So here you can see in the view labels, between the logical labels and the view labels, there is logical data independence. So whatever change you have done in this logical label, it should not affect your view labels. So suppose in your logical labels, you have defined a tables, that is instructor id of integer type, instructor name of varchar type, instructor address of varchar type also, and instructor salary of integer. And you only shown create a view for the clerk that is showing the instructor id, instructor name, and the instructor address. At the later stage, you want one more columns for the instructor tables, and you have added, right? That is department's name of the instructor. But whether it's change affect this view, instructor names, instructor address, no, because that is not affected by this adding of this. And if you want to delete that instructor salary as salary, then also it will not affect the clerk view, right? So that is exactly what the logical data independence means.
Sir, but
Oh,
so one question here, sir.
Yes.
If we delete any record in the view, I'm not sure what is the view, but
Yeah.
if we delete any record in the view one,
Yeah.
okay, will it not delete from the physical level?
So it's up to the whatever's the you set the constraint in your in a one data. Suppose this in the clerk, it is coming from only one tables. Then if you want deletes here in the view levels, then it will delete also the original tables. But sometime what happens, suppose you want to there is one department table also, suppose, right? Department tables, and the department tables has the department's name and department code and the department name, right? Hence the view, if you select, suppose your view is like select star from this, it will show from this table it will show instructor id, this table show the instructor name and instructor id, and the department code is coming from this table, right? You have created for the clerk view. Then if you run that in that time, so the delete, then it will not work, right? So it up to you how you have set your database, whether generally we not allow any view delete using this view
Okay, sir.
because the security purpose, right?
Oh, thank you, sir. Yeah.
So any doubt in this view labels, data abstraction level
In
of
logic level, if I change something, then it will affect in view also, no?
no, significantly not. So suppose in the view labels, if you display the instructor name, hence the if you logical label, if you delete that instructor column itself, then it will affect, right? So you got the
Yeah.
concept what is the logical data independence means. So that is important, right?
so sir, any change in logical level will not affect the view level and will not
Yes,
affect the view level, right?
yes,
This is
that
the
is the
basic
concept of
definition.
the logical data independence. So you
But sir,
have to
if
design your database in that way also.
if we delete any attribute which is in logical level and that same attribute as in view level also, then is there any chance that view level is affected and the user will not be able to see that attribute again or
Yes, yes, it
might?
is possible. It is possible.
Okay.
So you have to design your database in that way. Suppose you are a your database designer, right? So you have to design when which attribute are important for that view, and so that is the ideal situation. So you have to design this way. So you have to take care of this thing also.
And sir,
Otherwise, if you have to done again and again it's the same work.
in physical data independence, the logical and the view level, they don't, they are not
In
affected.
the physical data independence, right?
No, physical, yeah.
Yeah, yeah. And the physical data independence, whatever change you have do
Mm,
in the physical level, it should not affect the logical levels, right?
okay,
And if logical levels should not affect, then view levels is also not
not
affect.
affected.
So you can say this: whatever changes in the physical levels, it should not affect the upper
View
level,
level.
that is the logical levels and the view level. Yeah. Okay. Now coming to the database engine. So database engine is three components. The first one is the storage manager, and the second one is the query processing, and the third one is the transaction management. Right. So in the storage manager, so storage manager is your interface between the application. So suppose this is your application, and this is your physical levels, right, where the actual data is stored, and there is a interface between the storage manager. So by your application, whatever you fire any query here, so it will go to this storage manager, and this storage manager query the queries the physical levels, and it will output the result. So that is the concept. So here, so provided interface between the low level data stored in the database and application, and the application programs and the query submitted to the system, right? And you can also say that this is the interact with the OS files, file managers, that is your physical system, and so it will take care of the efficient storing of and retrieving and updating of the data, right?
Sir,
And
interact with OS file manager means
yeah, OS file manager means, suppose if your whatever's the data in your suppose you have uh, let's understand it in this way. Suppose you have your DBMS system, you have installed Postgre, right? PostgreSQL. Hello. Yeah.
yes, sir.
Yeah, PostgreSQL, right? So in the Postgre system in your computer, there is a file system, right? So
Mm,
at the deep down, it will whatever the data if you stored using the Postgre, it will already stored in the actual data is stored in your OS file system, right? And that is efficiently managed by your DBMS system, right?
mm, okay.
Yeah.
So whatever
So
file is
yeah.
getting in the
So
Postgres, that is getting stored in the
yeah, yeah,
file manager. Okay.
yeah, yeah.
Okay.
So that is, and there is a your interface, means your Postgre and your OS manager. So there is a between interface between that, and that is your storage manager. Yes, that is handled by this OS file manager is yeah, handled by this component, storage manager, right? And the second one is your query processing. So query processing has the three component. First one is a parsing and translation, and second one is the optimization, and then evaluation, right? So whatever query you have submitted, that is got parsing and translate into the relational algebra, and the in the relational algebra after converted, it will show which the for the same query, there is a different set of relational algebra is possible. So you have to pick up which is the efficient one. So low cost in term of the cost. So which is the least cost. So that will be executed by the evaluation engine, and then that will execute in your that relational algebra expression will execute in your uh, using this evaluation engine in your data, then you got the output of that query.
So
So
parser
that
means it's a one kind of translator.
yeah. No, parser means you have to parser is doing what it will check your whether it is a syntax error or not, right, in your query,
Okay.
right? So what is your query? Select star from some tables,
Hmm.
right? So if you instructor, let's take, so if you write from instructor select star, then it is a syntax
Hmm.
error, so that will detect by your
Okay.
parser, right?
Okay.
Okay. And the third one is your transaction management. So in the transaction management, you already know about the transaction is a collection of operation that will performance as a single logical unit of single logical function in your database application. So what this means, let me introduce this one. Suppose there is your, suppose understand it in this way. Suppose this is account A and this is account B, and you have to send 50 units from account A to account B, right? So for that, what are the process? So first you read the balance of account A. So that is the read A. So suppose initially A balance is 1000 and this is 2000, B is 2000, and you have to send 50 units, right, from A to B. So what are the operation, right? So first you have to read A, whatever's the balance of A, so that is 1000, and then you want to transfer from A to B, so that is first you have minus the whatever's value in the A, and then minus, right? Then you have to update, write A, you have to update the value of A balance, so that is the 950 you have to write. Then you reads the value of the account B, read B, so that is 2000, right? Then updates the value of this account balance, so that is 50, so that is 250, and writes the value into account, so that 250, then commit, right?
So
So
commit
all
is
this
the
operation,
end of.
this is a
Sorry.
set of operation, right? 5, 6.
So commit is the end of operation, right?
Yeah. It's the end of operation to whatever changes we have done in that database. It should, so that it should be permanent in that. So that's why we use the commit, right? So here you can see 7 set of operation, right? All these treated as a single unit of work. So that is called the transaction. This set of 7 operation. So this is
So
called
you mean
your
to say
transaction,
any
right?
workflow,
So
okay, set which performs that set of steps is called the transaction management, right?
yeah. So transaction means you have to understand a set of work. You define a set of work, right? So here I define, suppose this is my transaction one, right? This is transaction one. So I defines that in transaction once means you have to send 50 rupees from account A to B, right? So that is your one transaction. And what are the set of operation in that? There is a 7 set of operation in this transaction one. So all together is called your one transaction, right? Got it. So whatever changes, so that's why we said the transaction is atomic in nature, right? So what is the atomic in nature means? If you execute your transaction, it will execute all set of operation, right? Or neither, not at all. Means if up to this your set of transaction is execute up to this point, right, and that your system got failure, right, so then you have to roll back. So whatever changes you have done, so you have to roll back that to make your database consistent, right? You can see simple in your phone pay, you can see either it will got successfully executed or not at all, or your transaction got failure, right? So that is your transaction, right? You have to either
So,
you have to execute successfully or not at all.
so suppose if transaction fails midway, then can we the change the database to a consistent state?
Yes, that's why I done here. So up to this week 3, not step 3. So if your transaction got failure, right? So you have to roll back it. It will be automatically done by your system. So you no need to do anything
So,
to make it consistent. So here you can see that is the responsibility of transaction management component. Ensure that the DBMS system remain in the consistent state despite of your system failure or the transaction failure.
okay.
Right?
So there is no human intervention in
No, no. So
ensuring.
that is the advantage of your DBMS system. So
Okay.
that's why we use DBMS system, or in the file system, this provision is not there.
Okay.
Right? Okay. And here also you can see the concurrent control manager is also available in the transaction. So concurrency control manager, what it will do, it will, okay, so concurrency control manager, what it will controls the interact amongst the concurrent transaction. So you can see in the banking system for a particular accounts, the several user use that particular account, but it will in the inside the transaction only one user is use that particular system, or that particular transaction at a time, so on that particular data items. So you can understand in this way. CPU, you can see, you all knows that in the CPU only one program is run at one time, right? So that same thing is happened here also. It's the concurrent also. So yeah, and so that is handled by the concurrent is of transaction is handled by the concurrency control manager.
So,
I
sir,
hope it is
what you're
clear.
trying to say is that concurrency control manager kind of prevents simultaneous transactions on similar data, or does it?
Similar data items.
So it ensures or it prevents?
No, it's ensure that.
Ensures. Okay, that
Yeah.
simultaneous transaction on same kind of data is possible.
Yes,
Okay.
yes, yes.
Yeah.
So yeah, let me give an example. Suppose this is account A, and account has a 100 balance, right? This is balance. So at the same time, suppose this is B1 and this is C1 user, two user. They check the balance, right? Hello.
Yeah.
Uh, they check the balance. So first it will read the balance of account. So this is account A, right? So it will checks the what is the balance of account A. So it will show it, see that's the 100 rupees is there, and C is also check the balance of account A, then 100 balance, right? So if this B1 want to withdraw 100 rupees and C1 is also want to withdraw 100 rupees at the same time, right?
Yeah.
So if we allow the concurrent execution at a time, so suppose it will withdraw 100 rupees, it will also withdraw 100 rupees. Now can you tell me what is the bank balance of account A?
At the same time, we need to check whether there is at least 200.
Yeah, then it, if we allow the concurrent transaction here, so you can see that bank balance is, if both one is withdraw the 100 rupees is, so here you can see this is
Yes.
the minus 100. Yes, so that should not be allowed in the bank. So once B1 is uh, withdraw this money 100 rupees, it got balance is updated to 0, right? So whenever C1 is trying to withdraw 100 rupees, it will show that's the, you have the 0 balance, right?
Hmm.
So that is controlled by the concurrency control.
But thing is, if when we are doing these things concurrently, simultaneously together, different kinds of transaction, different uses.
Yeah,
So, yeah, concurrency manager is controlling it. But when you're talking about that balance, I mean, if I'm deducting 100 rupees and it is becoming 0, and
yeah,
the C person cannot, take the money out anymore because there's no money to take out.
yeah, yeah.
So in that case, the concurrency control manager, I mean, um, this section is going to be dealt with as in I have to make sure that I have enough money for both of these transactions to execute. So both of them will be taken together.
No, 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 that is a different from.
Okay, that's extended. Okay,
Eh,
okay.
so here you have to need to control this transaction, so
Hmm.
they are doing the transaction at the same time, right?
Hmm.
So you should not allow these things. Yeah,
Okay.
so one of them can withdraw that money. Yeah. So that is the concurrency. So that is controlled by this concurrency control manager. Okay. So I hope that's it from the week one. Yes, Bendu, you can continue with the two.
Yeah,
Thank you.
thanks, Pradeep. Let me share my screen. Am I audible, right? Hello.
Yes,
Yes, sir.
you are.
Yeah,
Okay,
yeah.
so we'll we'll see the what are the week week two contents. So yeah, in module 6, we learn about the attribute types like alpha string, alphanumeric, date, any number, etc., and how to create tables, how to uh, various
It
types
is
of data
showing
types.
week 3, Nathar. It is week 2,
Oh,
right?
so yeah, week 2. Yeah, it is. It is week 2. So this is the simply mistake. So this is week 2, right? So then we have learned about schema, right? So our A1, A2, and AN is a relational schema where A1, A2, and the AN are the attributes, right? And we have learned about the instances. So collection of information stored in the database at a particular moment is called an instances of the database. Then we have learned about various types of key like super key, candidate key, and the primary key. So what is super key? If values k are sufficient, suppose k and r, where r is the set of attributes in the relation. So k are sufficient to identify a unique tuple of each possible relation is called super key. And what are the candidate key? Minimal. Suppose no proper subset is uniquely identify each tuple is called candidate key. Then one of the candidate key is selected to be the primary key, right?
Sir,
Then
please take examples and explain.
So,
Something.
so
yeah,
one question on this,
yeah,
given a relationship, say it has 5 attributes, how
yeah.
do we calculate the maximum number of super keys
Okay,
possible?
okay, okay, okay. Let me explain. Okay, okay. Sorry. My screen is visible. Hello.
Yes, sir.
Yeah.
Yes, sir.
Okay,
Yes, yes.
okay. Suppose. Okay, let me give a small example. R.
One example, for example, you take student info, which has enrollment number, class, section, role, and name.
Let ABCD. That will be better. Hello.
Okay.
So
Okay.
Bindu, you can take that question that is from a practice question to
Correct.
from,
Practice
yeah.
section 2, think that
We already discussed that question in the previous session.
Okay, let's give me one example that will be better. Suppose there are 3 attributes, right? Or 4 attributes. Oh, okay. Suppose there is a, it is given, or suppose in week 5 or week 4, if it is given functional dependency, you can find the candidate key. And suppose it is the given A is the candidate key, right? A is the candidate key. You have to find the numbers of super key, right? So you can see that there are 4 attributes. So what is super key? So it will be A, then AB, then AC, then AD, then combination of 3 attributes, right? ABC, uh, ACD, like that.
Sir, what is
There
meaning
will,
of super key, sir? Can you just explain, sir?
okay, minimal super key. Suppose like so you can see that A is the candidate key, right? Okay, let me give me another example. AB is the candidate key. So minimal super key, you can, if you find AB closer, so you can find the ABCD. Minimal super key means no proper subset. So proper subset of AB is A plus, proper subset of AB is A and B. So if A plus give, it does not give all the relation ABCD, does not give. The, if A plus give all the relation, then A will be the candidate key, not AB. AB will be the then super key, right? So no proper subset give the all, uniquely identify all the attributes. So that is minimal.
So basically, in order to get a candidate key, we cannot reduce any more columns, right?
Yeah.
AB will be the minimum requirement to make sure that it acts like a primary key or a candidate key or
Yeah,
anything of that sort.
yeah.
Yeah.
So you can see that a combination of all the attributes, right? So you can see that there are, if there are 4 attributes, you can, if you power set, if you know the power set, so if A is the candidate key, then we can find that 2 to the power what, there is 4 attributes, then 4 minus 1, right? So 2 to the power 4 minus 1, it will be the to the power
Excuse
so
me, sir.
8. Yeah.
Sir, can you please explain this practice assignment 2 question, which is similar to the one you are explaining right now, because I'm not able to understand that.
Okay, let me give you know, we have already discussed in previous session. You can also watch the session. So give me one a small example, that will be better. I think you will all understand. A, B, C. So if A is the candidate key, what are the super key? Can you tell?
AB,
A, then AB,
AC,
then AC,
then BC,
ABC.
okay, BC, then
and ABC.
okay, then A, B, C, right?
So BC cannot be. A is a candidate key, right?
Yeah, BC is
A has
candidate.
to be there.
Yeah, A is to be there. So yeah, BC cannot
Okay,
be. So can you tell what are the how many?
4.
1, 2, 3, 4,
Mm,
right? 4 super key.
mm.
Okay, you can see that. So if there are 3 attributes, so you can combination of all the, right? So you can, so if there are 3 attributes, so if A is the candidate key, right? So you have to exclude. So 2 to the power 3 minus 1. So that will be 4,
So -1 for
right?
what?
So you can see that there this A is the candidate key.
Mm-hmm.
And that's why.
Okay.
So you have
So
to
like
combine.
if AB was the candidate key, then we would have done 2 to the power 3 minus 2.
Yeah, because you have to combination of all the attributes, right?
Right.
So we have to include A also. Combination of include A all the attribute. That's why -1. So I think it is clear. Okay. Everyone is clear with that things.
Yes, sir.
Okay. So and you can no I think practice question you can practice in your, or you can also watch previous lab session.
Excuse me, sir.
Yeah.
Sir, in the practice session, there are two candidates key given. One has only one element, and the other candidate key has three elements.
Yes, yes.
So accordingly, the answer should be five, right?
No, so
So
see.
Bindu, you can do that also. So R, you can take A, B, C, D, E, and take A as one candidate key, and one is a B, C, D is one candidate key.
Okay.
A,
So
B, C, D, E.
yeah.
Yeah, and candidate key is one candidate key is your A, and the second one is a B, C, D.
B, C, D. Okay.
Then finds the maximum numbers of the super keys.
Okay. Then what will be the maximum numbers of super key? So first we have to find the, with the help of A, how many super key. So it can be A. You can see that combination of all the attribute A, B, A, C, A, D, A, E, then A, B, C. No. Uh, uh, we have to find the ACD, like so. If you A is the candidate key, how many super key will be possible? 1, 2, 3, 4, 5.
So I think it's 2 to the power 5 minus 1. So if you
Yeah.
have got n attributes and k attributes are in the key, candidate key,
Yes.
the total number of super keys possible is 2 to the power n minus k. So here k is 1 and n is 5.
Yeah. So how many or will be the,
2 to the power 5 minus 1.
so to the power 5 minus is to the power 4,
4, which will be 16.
which will be 16, right? Okay. Then you have to find the, you have to, if B is B. Okay. Then BCD is the candidate key. Then we have to find the how many super key possible, right? Hello.
So here k is 3,
Is
right?
K,
n
K
is
is
5.
3. Yeah. So what will be the 2 to the
So
power
2 to the power 5 minus 3,
2 to the power 5 minus 3. So what will be the,
4.
yeah, 4. Then you have to see the common attribute also. There are some common attribute, because you can see that in the A also A, B, C, D also will be there, and B, C, D case B, A, B, C, D also there, right? So you have to see the common attribute, right? Hello, am I audible?
Yes, sir.
Yes, sir.
So
Yes, sir.
so you have to see the common attribute. So you can see that uh, so you have to see the A, B, C, D. So there are, you can see the 5 elements. So if there are 4, so 2 to the power 5 minus 4, we can see that 2 to the power 1 equal to 2. So you have to subtract the common attribute. Then 16 plus 4 minus 2 equal to 18 super k. Everyone got this?
So the common one is done
So this,
for the candidate keys. Like there is nothing common between A and B,
Sir, the
C, D.
last one, sir, can you
Oh,
explain
yeah,
once again?
please explain.
16 plus
yeah,
4.
yeah. So see, with the help of A, how many super key find? 16, right? With the help of B, C, D, 4 super key found, and we can
Mm-hmm.
see that there will be the repetition. Like in the A, B, C, D also be there, and the B also A, B, C, D will be there. So there will be some repetition, right? So you have to subtract one, so that the super key, there are duplicate, right? So you have to subtract one. So you can see that with the help of A, B, C, D, how many super key found, right? So to the power, there are 4 attributes, to the power 5 minus 4 to the power 2. So these two attribute will be the common, right? So you can, with the help of A, 16 super key is found. With the help of B, C, D, 4 super key is found. Then you have to subtract common attribute. Then 16 plus 4 minus 2 equal to 18. Basically, what will be the A union B? Number of A plus number of B minus number of A intersection B. In the mathematics, I hope you have learned. So
So
here,
yeah, this is set theory. That's fine. I think the cardinality of AB is very clear because
yeah.
it's true to the power, but the common one is not trivial because that's the one.
So common one is got it, or shall I repeat?
Common one is
Yeah,
A, B,
If we
C, D,
take
right?
ABC,
So see, common, you can see that BCD is the key one, and one is the A is the key, right? So we have to
Yep.
find the what are the with the help of common attributes, both are the coming, right? So how many super keys found? You can see that with the help of, if there are four attributes in the 5 elements, so you have to 2 to the power 5 minus 4 to the, so 2 to the power 1 equal to 2.
Excuse me, sir.
Okay, so let's one a small example that will be better. Suppose A, B, and C, right? So A is the candidate key and B is the also candidate key. So you can see that you have find the, we can see that common is repeated like AB and the ABC. These two are common, right? AB is the candidate key. So how find 2 to the power 2 are common, right? So AB, with the help of AB, how many super keys found to it? AB and the ABC. So 2 to the power 3 minus 2, that will be 2 to the power 1. In that case also, with the help of ABCD, how many super keys found? That will be the common, right? So 2 to the power 5 minus 4, this is equal to 2. So I have, you got it, or
So here there are two cases, right? So there is a candidate key set one, there is
yeah,
a candidate set key two. So here both the sets like A and BCD, there is no overlap. So that is one case. The other case is, let's
Hello.
hypothetically,
Yeah.
uh,
Uh,
yeah, AB, and then BCD. These are the two candidate keys. Then I think the numbers will be different.
Hello. Yeah, Smith. So here you can see by using this candidate, you have create the super key. So one possible super key is using A. One is possible super key is A, B, C, D. Possible using this candidate key A as a candidate key. One super key possible is A, B, C, D. Right. That is possible one. And another one is A, B, C, D, E, right? Subendra,
Yes.
can you write that?
yeah.
Using A, there is one using, clearly you can write from using A. Can you erase some and write? That is, I hope that is not clear. Okay. Yeah. Under the A1, you can write the possible super key is one A, B, C, D. This is possible using A as a candidate key, right? And
Yes.
another one is A, B, C, D, E. Now consider B, C, D as your candidate key, and possible super key is B, B, C, D, A, right? Yeah. And another is a B, C, D, A, E, right? So when you calculate using A, you count this one time, and B, C, D you have calculated another time also. So when you plus 16 plus 4, you count this combination twice. So that's why we minus 2.
Yeah, makes sense, sir. So here, the candidate set one has one element. The second set has two elements. So since there is no overlap, when we take the superset of candidate key, it is 1 plus 3, 4, because there is no overlap. So then the answer is 2 to the power 5 minus 1 minus 3. But the other scenario is if we take the same relation, A, B, C, D, E, but now we change the question. We say AB is one candidate key, and then BCD is another one. Then I think because now we are creating overlap between the candidate sets. So that will be another variation of the same question, but will lead to different answer,
I
different
think
question.
that
Yeah,
discussion is not reaching out to the same page. You are explaining something, and Pradeep is explaining something
No,
else.
no, no.
So
Okay.
fundamentally, the rest of the audiences are just in the dark and confusion.
Yeah, yeah.
We are
Subendra, can
wasting
you
time
stop for
now.
a moment
Can
so
you,
that I
for the
can
benefit
explain?
of everybody, can you clean up the whiteboard and just start with A, B, C, D and give all the combinations and the final formula? That would be the easy and
Yeah,
quick one for everybody.
Okay, so let's explain. See, see, A, B, C, D, or no, let's S1. So if A is the candidate key, only A is the candidate key. With the help of A, how many super key can be found? A, then AB can be found, then AC, then ABC, right? Hello, hello, am I clear?
Yeah,
Am I
yeah.
audible?
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir. Yes, sir.
Okay,
So
sir.
see, there are three attributes, right? Three attributes, and the A is the candidate key. So with the help of, we can find 2 to the power 3 minus 1. So to the power 2 equal to 4. You can see that there are 4 candidate key, right? 4 super key, right? So with the help of A, we can find 4 super key, right? This is the one case. So you got it.
Yes,
Everyone
sir.
got
Yes, sir.
okay. And suppose A, B, C, A and the B is the candidate key, right? So let's us find with the help of A how many super keys found. With the help of A, you can see that A, AB, AC, and the ABC is the super key found. With the help of B, you can see that B, then BC, then BA, and ABC is found. So we can say that with the
Yes.
help of A, 2 to
Yes.
the power 3 minus 1 equal to the power 2 equal to 4 super key found. And with the help of B, B is a candidate key. So you can see that 2 to the power 3 minus 1 equal to 2 to the power 2 equal to 4 super key found. But you can see that A, B, C and BA will appear twice. So you have to subtract once, right? You have to
Yes.
subtract once.
Yes.
So with the help of AB, with the help of AB, we have to see what are the super key with the found. So you can see that AB and the ABC. These are the AB and the ABC. These are the we are counting that twice, right? So you have to
Yes.
subtract, right? So you can see that there are three attributes, right? To the power 3 and there are 2, right? So you have to the power 2 equal to 1. So to the power 2 to the power 1 equal to 2. You have to subtract. If you see in the set theory, number of A union B equal to number of A plus number of B minus number of A intersection B, right? So with the help of A, we
Yes.
will find 4. With the help of B, find 4. And the intersection B, AB is equal to 2.
6. 2.
Sir, what is the formula to identify the duplicates, sir, here? Just now, like you did like 2 ki power 3 minus 2.
Yeah, yeah.
So 3 is a like a total number of elements in the
And
set, right?
and if there are 2 attributes, you have to find a
So
2, right?
minus number of keys, right? Number of keys,
Yeah, number.
A or
Candidate
Yeah,
B.
keys.
yeah. So there
Okay,
are
number
4
of
plus
candidate
4,
keys. Okay.
8 minus 2 equal to 6. So there are 6 candidate key. Can
It's
see
super
super
key.
key. Yeah, it's found. You can also count A, AB, AC, ABC 4, then B and the BC. So
BC.
there are 6 super key found. I hope everyone
Sir,
got it. That's it.
sir,
Yeah, yeah,
sir, when B is candidate key,
yeah.
then how this will be four? How this will there will be four super keys.
So
There is only three in a B, BC, and BA.
you can see that with the help of B and the BC, BA and the ABC.
ABC, ABC, ABC.
Oh yeah, sir, yeah, got it. Okay, thank you.
So like one of these people were saying just a couple of speakers before this, the number that we are going to deduct from the total sum of 4 and 4
Yeah,
is 2 to the power 3 minus 2. That is what you've done. So 3 is the total number of fields in this relationship, right?
yeah, yeah, yeah.
And 2 is however many variables we are using to
Ah,
create
yeah.
the keys.
Yes, yes,
Okay. So total minus whatever we are using.
yes, yes,
Okay.
Total attributes minus candidate keys.
yes. So
Attributes, yeah.
Sir, can we call candidate key as a super key also?
Yes, we can call candidate key is a super key.
Minimal super key, right?
Yes, yes.
Sir, can we proceed with the joins or types of join?
Yeah, I will see if the okay. Then in the module 6, secondary key, alternate key. Candidate key other than the primary key is called alternate key. Then simple key consists of a single attribute. Then the composite key consists more than one attribute to uniquely identify each tuple in a relation. Then we have done foreign key and the relation query language like procedural programming and the declarative programming. Right. Sorry. In the module 7, we have learned project operation. So it selects rows and the tuple. Suppose there are is the uh, suppose the and the 1 2 3 4 5 6 7, so sigma d greater than 5 the relation r, so it will at 6, right? Then the projection operation, the selection of columns or the attributes. Then we have run union of two relation, difference set difference of two relation r minus s, intersection. Then the Cartesian project, joining of two relation, it is denoted as r cross 1s. Then the natural join relation on two relation matches two tuple has values the same on all attributes names that are common to the both relation, right? Then in the
Sir,
module,
Sir, one question here.
one question.
yeah,
Yeah, go ahead. Go ahead,
Wait,
sir. You go ahead. Go ahead, man.
yes,
hello, sir.
someone has some question.
Sir, in the union operation, we have if we have the same number of attributes only, then we can do the union, right? Of
Yeah,
two relations.
Domain
yeah,
and arity, yeah.
yeah, domain and the arity will be the same, right?
Domain. Okay.
Yeah,
Sir, my question here is like this is regarding the project operation and the select operation.
yeah.
Okay, in the project you mentioned like is a number of the the columns we select, that is the kind of we define here.
Yeah,
Okay,
project operation,
yeah.
yes, selection
But
of
in the
column.
select operation, you said rows and tuples, sir. Sir, tuples can be on only few column also, right? Suppose
Tuples,
I have in the one row, I have 10 columns are there.
okay,
So if I choose only two columns from there, so
yeah.
can I use select operation over there? I mean,
Yeah,
so
we can. Yeah, we can do that. We can do that. We can project, then we can select operation. First project, then what are the condition? In the select operation means in the SQL we can think like where condition,
okay, okay,
and project operation you can think like select. What are the select
okay, okay. Yeah,
like that?
thank you.
Okay. Okay. Then in the module 8, we have learned about the DTL command, how to create table, how to drop table, how to alter in the data manipulation language like insert, delete, and the modify table. And the basic SQL structure is like select from where. Select means what are the attributes are selected, and the from which table. The where pick what the condition, right? What are the condition apply on the query. And the module 9, we have learned Cartesian product. So it generate every possible pair, like select extract from instructor and teacher. It generate every possible instructor and teachers pair with all attributes from both relation. Then we have learned how to rename the column or the operation, right? Then the string operation. So the percentage means character matches any substring, and the underscore character matches any character. Then we have learned about the order by. So you want to order into the descending or ascending. So by default it is ascending. If you write order by default is ascending, and if you want to descending you have to write DSC, right?
Sir, Cartesian का example ले लेंगे sir एक बार. Can you please take example of Cartesian product, sir?
Okay,
I have issue here in this thing.
okay, okay. Suppose there is a relation A and the relation and the B, right? So relation A consists like 1 2 and 3, and the relation B consists like 4 5 6. Whatever the, if you write select, this is a suppose R and this is a S, right? Select start from R S. What will be the query? It will query A B. What will happen? So it will pair all the, like first one,
Nine. rows.
Yeah, 1 4, then 1 5, then 1 6, then 2 4, 2 5, 2 6, then 3 4, like that, 3 4, 3 5, and the 3 6, like that. So did you got it?
Yes, sir. Okay.
So percentage is fine. One example of underscore thing.
Okay.
So is string operation example.
Oh, okay, okay. Okay. So okay. Suppose if you want to find the, you know, suppose there is a name attributes and there is a various name like Ram, like Abhi, and the like, you know, Rakesh. So if you want to find the, you know, the name character a consist or not, a small a consist or not, so you can write the select name from table name where name like,
Percent a percent.
so you can write, you know, percentage a percentage, like that. So you can see that this will be the selected and this will be the selected. So if, so this will be the substring or not, a is the substring or not. If you want to, you know, select where the and h or not, so you can write simply percentage the h. So percentage matches with it, any character, right? And it will, at the last it will check h or not. And suppose if you want to see this, there is a name like only b, so you can check the, no, name is one character or not, so you can check simply like that. So it check only one character or not, like that. Okay. So string operation is clear.
So can you show one example of the escape character?
uh, one example, what is
Then string operation through escape character
escape character?
means black cell.
I think escape character is not there in the syllabus, so you can try out also. Okay. Okay, then string operation is clear, right?
Hello, Samit. Uh, Samit, right? Are you asking about escape character in string operation?
No, I'm just asking because lecture in
Yeah.
lectures is there.
So suppose if you want to match the string, it has the percentage sign in it. So if you want the name of a student who has received greater than 90%, and in the column percent sign is also there, so 90%. So if you use this percentage sign, then it will be considered as a string operation, like in SQL. But if you want to match that percentage sign also with the column field, so you can use escape sign there, that is slash, right? So in that case, that percentage sign will be also considered as a one separate character.
Yes, sir. That is why, sir, if the original string having some percentage character and I want to match, suppose from percentage character to end part, then how should I write? Means first backslash, then percentage, like this.
Yeah. So you have to use the slash percentage and then percentage. You can try that. Yeah.
So first percentage gets escaped through that escape character, and second
Hmm.
thing, it is originally what is the meaning of percentage in SQL that we consider, right?
Yes. Yeah. You can try it on in PG admin also. You just create one column and try to add that. Yeah. Okay. Yeah.
Okay. So then we have learn about the, you know, if you want to fetch the top 10 rows, or then in the, this is the not work in the PG admin, this query works. So if you want to find the top 10 rows, right, so you can write fast fetch first 10 rows, rows only. And if you want to find the only 3 rows, you can write fetch first 3 rows only, right? Like that. And this is the order by name. It will by default, it will uh, no uh, by default is ascending. And if you want to find descending in order, right? So you have to write order by name descending, like that. Then we have learned where's clause predicate. So if you want to put some condition into the, so you can where clause. Then the in operator allows you to specify multiple values in a where clause, right? Like that. Then in the module 10 we have learned about various types of set operation. So union, intersect, accept. Then the null values. So null signifies unknown value, that or that value does not exist. Then we have learned about the aggregate function like average, mean, max, and the sum, and the count star. And the one important point is all aggregate operator except count star ignore tuple with the null values on the aggregate attributes, right? This is the important points.
Sir, can you
And
speak louder, sir? Your voice is coming very low, sir.
okay, now it's clear. Hello,
Yeah, it's fine, sir.
hello. Okay, so average return average value, and the minimum return the minimum value, the max return maximum value, and the sum return sum of values, and the count return numbers of values, right? So suppose there are instructor name and the salary. So the AN salary is 40k, and the B salary is 30k, like that. C salary is 50k. So if you return select mean salary from instructor, so it will return the mean salary is 30k, right? If you return the max salary, it will return max, right? Like that. If you write average salary, it will average, right? 40 plus 30 70 plus 50, it will return 40 plus 30 plus 50 divided by 3, right? Like that. And one important point is all aggregate operator except count star ignore tuple with the null values, right?
Sir, if
Then
I want to fetch the second max record,
yeah,
so how to find second max record, sir?
so you can use the limit operator. Okay, so how to find the second? Okay, see. So you can write select. So if you want to the name from instructor, then we can write uh, order by salary descending. You can write limit 1 offset 1. You can second, whatever the second hash salary, it will return. Or you can use the correlated query also.
So what is value? So limit offset, then what is the thing you use? One.
Limit
Limit 1 offset 1.
limit 1 offset 1.
So it will first offset the first row, and then it will retain the second row by using
Yeah,
limit 1.
it will.
Okay.
And you can also use the correlated query. So you can try in your own correlated query.
You
So
nested
correlated
query,
query
right?
also, nested query. You can try out.
Okay.
Okay, like that.
Sir, can you
So can you look
explain
at,
about the accept all or intersect all, or in a difference between these two, sir?
Okay. So yeah, I will s- I will give one example. Okay.
So this
So
one limit one offset of one, sir. This one.
yeah, limit
Last.
1 offset 1. Hello. Yeah. Hello. Am I audible?
Yeah, yeah. It will give what it will give limit one offset one.
So it will give the second highest name of the person, second highest salary. So what will do? Offset 1 up so we have order by salary descending, so it will salary like 50, then 40, it will arrange in the descending order, right? And the 30 offset one means after the one it will select how many rows after the one. You have to offset mean how many rows after that, so it will accept means after the one limit on means this value, right? So it will print the second highest salary. So if it is limit 1 offset 2, then it will be after the tuple of 2, right? 1 2, it will print the this 30.
No,
So that will
limit
be
one.
third highest.
Yeah. Yes. Yes.
Go ahead.
Hello. Someone
That
said
I said,
something.
if we are to lay the kth largest, so we have to offset k minus 1 and then limit 1. That will give us.
Yeah.
That's
Yeah. Okay. Okay. So.
Sir, can you please look at the chat? We have posted a doubt.
What is that?
It was
I did
a
not got it.
link of a paper, previous year paper. We had a question.
Yes.
Yes, yes, I am taking that question.
Okay, sir.
Is it that related to week 2 that Subhendu is explaining?
It's related to the subquery, sir.
Yeah, so I will take that. Let Subhendu
Okay,
complete
sir.
this part. Yeah.
Okay. Then someone asks about the accept and the accept, all right? First, let's see union and the union, all right? Suppose there is a 1 2 and 3. This is the A, and suppose B, suppose 2 3 and the 4, right? So what happens? Suppose if you do A, this is A table and this is B table, right? A union B, it does not return the duplicate. So what will happen? And this is suppose also A, right? There are two relation A B and the A. It will return A 1 2 3 and the 4, right? And this is union, and if you write A union all B, so it will return the duplicate. What will return? 1 2 3, then 2 also, right? 2 and 3 also. This is A union all. So this is A union B. So everyone got it, union and union all?
Yes, sir.
Okay. Then accept and the accept, all right? So okay. Okay, so that's, suppose there is a let's say example. Okay, so 1 1, then suppose 2, and then there is a 1 1 2 2, right? And this is relation A and there is relation B. This is A 1 and the 2. So and they suppose there is a 3 also. So A accept B, what will return? It will returns only the 3. And if you do A accept and B, it will return, it will no, it will subtract only one subset. So it will returns A 1 2 and the 3. it will subtract only one subtract. So this will subtract only one set, right? If you can see there one two times, so it will subtract only one times, not the two times. So I have got it accept and the accept all.
So,
Hello, someone
when
is
we
there?
use when we use accept, okay, so it
Yeah,
will remove all the duplicates value also and all the
yeah, yeah,
elements in the A, right?
yeah, yeah, yeah.
Okay. And when we use the accept all, so only
Only one
number of
set.
elements given there, only that will be removed from the first set.
Yeah, only yes, yes. Only one set will be removed.
One set will be removed.
Yeah, like that.
I'm actually very confusing, sir. Actually, that's the thing.
Yeah, yeah. So I think you got it now.
Yeah, the name is reverse.
Yeah.
It is counterintuitive.
Okay. Okay.
Yeah,
So
counterintuitive.
then,
That's right.
okay. Then group by clause we have learned tuple with the same value on all attributes in the group clause are placed in one group. It will group by. Then having, so after the group by you can put condition. After the formation of group you can apply some condition. This is called having. So this is the week 2. So if you have any doubt you can ask, otherwise we will go through the week 3. We'll go into the
So any operator, it's same like in operator.
any operators
Suppose,
uh,
or is it coming week 3?
yeah, we will in operator will discuss in we have learned in detail in week 3. So in operator you can see you
Not
can
in, sir. I am saying ki any,
Sir,
ANY.
any can be used
Any
in
of
place of some, sir.
yeah sometime both are somewhere and both are different, but yeah it can be used
no,
both are
is there any difference between any and in?
any and the in. So say in operator what will check, suppose let me give one example. Suppose we select so there is a instructor table and the name and the department name. So the name is department name, like a name is A, department name is music, B also music, C computer science, CS like CS computer science, D is like mathematics, E is uh, E is like biology, right? So if you want to find the name of the instructor who are belongs to music and the biology department, so we can write select, sorry, select name from instructor where department name in sorry in music and the biology department, right? So you can write bio. It will check if it is, so what will return, name of the instructor whose department belongs to either music or bio, so it will returns A,
In.
then B, this is the name, right? And the bio is E, right? So the bio is like that. So any operator checks belongs to any operator check. Suppose if you want to find the means any, it's whatever the you can bracket, you can put any, right? Like that.
No, here,
Yeah.
instead of in, can I write any and that will lead to the same result?
Uh, this here any, right?
Hmm.
Mm, you can check in the PG admin also, right? So let's check in the PG admin. Okay.
Sir, any can be used in place of some, not in place of in.
Yes, yes. So he is asking. So let's.
Sir, for tomorrow's exam, do we need to concentrate well on triggers and procedure, functions and procedures also?
Uh,
Because in mock test, we haven't got a question on triggers,
Uh,
functions and
you can
procedure.
go to this concept like theoretical part. That's it.
Sir, we have to remember syntax also, or we have to do the computation also for
No,
trigger.
for trigger procedures function, just go to the conceptual part, theoretical part. Like for what
To,
purpose we use triggers, what is function? Yeah, that's it.
Sir, how many operators, like just now, somebody brought that sum and any operator. So, how many such operators are there? Actually, I'm aware of only few only. So, how many such operators are there? Like we can use it here? Or I mean, can you just tell me what is the use of any and sum? So that will be enough for me.
so any means in the subquery, if it is message any, right? So it returns true. So and in the sum means like any and sum both are same like any and sum. If it is matches and matches in the subquery, suppose subquery whatever it matches any of the things, it will return true like that.
So in also do the same thing only, right?
Uh, yeah, in
In is a membership operator. It
No,
checks whether it
uh, in
in and
operator will
not
check
in.
whether that particular attribute is there in the list or not. Any means simply it will check whether it is matches to any of the attribute. That's it. In means you are applying multiple or conditions to the particular attribute. Both are different.
I doubt.
Sir, opposite to some will be what?
Opposite to
All.
some will be all, right?
All.
yes. Okay.
Sir,
So
I'm having one
some,
query. Sorry,
so
go
some
ahead.
can be at least one.
Yes. Some can be
Some
at
can
least,
be at
yeah,
least one.
at least one, yeah.
So can you take an example, sir? You're right now you're showing it something database, right? So if you, it's good like if you take from there.
Okay. So yeah, you can also so see this see the concept. Any in operator if it is message like that it will return true, right? Some it's uh, like if at least one then it will return true like that. So you can also uh, you know write your query and you can test in the PG admin, because this is the summary session already 10:24 and we have to also cover week 3 and week 4 also. That's why you can also try. Hello.
Yes, sir. Yes, sir.
Yeah,
Sure.
yeah. Okay, then we'll move to the week 3, right? Okay, so in the week 3 we have covered select distinct, select all, then the Cartesian product, basically overview of week 2, where and or, then the string operator, then the order by. So then the order by can be ascending or descending, then the in operator, then the set operation like union all, intersect, except all, then the aggregate function like average, mean, max, count, and the sum, right? In the module 12 we have learned about the various types of nested query, right? So a subquery is a select from where expression that is nested within the another query. So
So one doubt, sir.
yeah,
Like when we are doing a select with a group by and having clause,
yeah.
and suppose there is a like operators like sum, average is there in the select, then that has to be there in the having clause or what?
Okay, so see, so what about the uh, other than the aggregate function? Okay, suppose we can select department name, and suppose this is a another constructor salary, right? So select department name and the average salary. So from instructor group by department name. So other than the aggregate function, whatever the attribute is present, right? So that must be appear in the group by clause. So it must be appear in the group by clause. That's it. Other than the aggregate function. So other
Sir, in
than
the having there is no such constraint.
yeah, you can in the having clause you can put the average salary is greater than average salary greater than 30,000 like that or anything like that. Okay.
Sir, here in this having clause, sir,
Yeah.
so the condition we are putting here, we can put department name also, right? Department name, something equal to this thing. So,
So, if department name something like that, so you
yeah,
can in the put in the where clause also.
no, that's fine, that's fine. I'm not talking about very close, okay? I understood
Yeah.
you this thing. But
Yeah.
what my question is, so the whatever condition we put here, whatever column we mention in the having clause, is
Yeah.
that column has to be present in the select statement?
Yeah. So what? No. So what about the select statement is the present other than the aggregate function? Whatever the it must be present in the
Yeah,
depend.
okay.
If you are using aggregate function like so, whatever the other than the aggregate function must be appear in the group by clause. That's it.
So in having clause, I can put any other column also, which is not present in the select statement, select clause, right?
Yeah. So yeah.
Okay,
Yeah.
that's what my question. Okay,
Yes.
thank you, sir.
So this group by you have selected the department name. If
Yeah.
select clause having more than one, the department name and name,
Yeah.
then both should be present at group by or any the first one can be enough.
So see, suppose this is the department name. So it will the group by department. You can see that there are music, CS, MA, and bio. So it will return music, and then whatever the average salary, and whatever the music, CS, MA, bio. Then CS, then MA, then biology. That's it. That will be the present.
No, that is okay. I know.
Yeah.
Asking if select
Yeah.
having say three, say department name, then category, and then average salary. Now, when I'm grouping this,
Yeah.
if I write this group by only department name, is it enough or I have to put department name, comma category, both? Because both is
Yeah.
present in select.
Yeah. You have to both. If it is you can write select department name. If you write name or like if you are writing category you have to write in the category also group by department and the category, and it will group according to the department name and the category based on the common value, both department name and the category.
Okay. And so my another thing, sir, can you just say suppose in this SQL statement,
Yeah.
select from group by Yadi,
Yeah.
what is the flow of operation?
Okay.
Operation first from where to start and how it is flowing. So can you just
See, select department name average salary from state, right? Group by department name, so it will group the department name according to the common values of department name, and the average salary. So according to the group, it is average salary. What are the average salary according to the department one? Then if you then you can write having average salary is 30,000 or not. It will check the 30,000 is not if it is 30 greater than the 30,000, it will print. If it is not greater than the 30,000, it will not print like that.
suppose in the from clause if instructor and comma say student is there,
Instructor
then
comma student. Yeah.
then what is the flow? First
So
it will make the table.
yeah, select from instructor and department. It will cross join. After the cross join, it will group the according to the common value of department name. First, it will cross join right from instructor and the student. So it will make cross join first.
Sir,
Then it will
can we
First,
revise some
first it
joints?
will make the
yeah
first it will
Join.
make the table. Then it will go for the grouping by
yeah
and then
yeah.
and suppose in between group by and form we have some where clause. Then in the flow where this where clause will be executed after the table or
So
after the group by.
after the formation of table, it will what are the condition? So it will select according to the condition after the group by clause will no group after the
So where clause will be applicable first? This means before group by.
yeah. Okay.
Okay.
Yeah. Okay. So we have learned about the sum, any, all, exist, not exist, and the unique also. Then in the subqueries in the form clause, we have also seen the subquery in the from clause, and we have also seen the modification of the database like deletion of tuple, insertion of new tuple, and the updating value of some tuple in the given relation, right? Then we have learned about the various types of join. So we have learned about the cross join, then the inner join, NICU join, and the natural join, and the left outer join, and the right outer join, and the full outer join, and the self join. So
Sir, equijoin is not explained to us. Like Sir had just mentioned once, he didn't give any example for equijoin.
okay, so, equijoin like that. Uh, Suppose
Sir,
the
please take example of each joint, sir. Just overview only, sir. Will be great, sir.
okay, so cross join like suppose there are instructor and teachers. Instructor. Okay, let me give one example. Yeah. So let, mm, so this is the suppose there are manager table and the teams table, right? So manager table consists of name and the team ID like that, and team table like team ID. This is the manager name, and this is the team ID and the name of players and the jersey number, right? So if you first cross the right. So I think so. What will question how to write? Select start from manager and the team. So it will appear in the all the attributes, whatever the combination of all the attributes manager and the team. This is called cross join. Select start from managers and the team. So everyone got it? What is cross join?
Yes, sir.
Okay. Then the equation.
So
Equation.
it will pick all the records, right?
Yeah.
Cross join.
Yeah. All that. So we were also seen. Suppose there is A and the B. So this is the two table. So A is the 1 and the 2, and B is the like 3 and the 4. So if you do cross join, so what will first AB whatever first 1 3 1 4 2 3 and the 2 4 like that.
So it's written the Cartesian product, right?
Yeah, Cartesian product like
Okay,
that.
that makes sense.
So
Okay.
yeah, you can see also in the I think 3.3 all the join is explained in the in the very good way. So you can see that. So it will cross joining operation. Okay. Then inner join. So inner join whatever the common attribute common the tuple, right? So you can see that the this suppose this is the course ID. This is whatever the two table. Okay. So this is the two tables. So you can see that inner join what will happen. You can see that bio 301 bio 30 is matching, right? Bio 301 bio 301 matching, and CS190 is matching. So inner join appeal no common value, common whatever the common attributes like that. So uh, everyone jotted inner joint. Hello.
So sir, you mean sir inner join will return the duplicate column also?
Yeah.
Operation, right?
Yeah, I did not got it. Can you repeat?
Inner join is basically the operation when we do the between two
Your voice
relations
is
or something
breaking.
like that.
Manan, your voice is not clear.
Okay.
Hello.
Yeah.
Okay.
Hello.
Yeah. Please tell me.
Yeah, so sir, I was saying that inner join is basically the intersection operation which we perform on two relations. If we have any common attributes, sorry, common tuples which are in both the relation, then we try
Yeah.
to
Try to.
fetch
Yeah.
that. Okay.
Yeah. Then
Okay, sir.
we have learned. Then we have learned about the left outer join. So what about the left table will be first we will message the common attribute. Then it will check every attributes what are the every tuple is present left tuple or not. If they're not, then it will exist. Like first bio 301 is you can match by 31. Then CS 19190 is match. You can see that two tuple will be there, but CS 315 is not present. So CS 315 will be there, and in the prerequisite ID it will be the null, right? So in the left outer join, all the tuples of the left tuple will be there.
So what will be the table? I mean the select query for this thing. So you were saying like we will bring all the records from the left table mentioned, right?
Yeah.
So how system identify this is a left table, sir? I mean, can you
Okay.
write the syntax of this thing?
Okay. So like you can, this is suppose this is the A table. So this is the A table and this is the B table, right? So select whatever the select start from A left outer join. This is the natural left outer join. You can like natural left outer join B. So this is the left and this is the right. That's it. Hello.
A left outer join B. So it
Yeah.
means A is the left table, right?
Yeah.
It
A
will.
is the left table like that.
Okay, sir.
Sir,
Okay.
if we
So we
drop the
use the
natural,
on operator here.
Uh, on operator means I did not got.
We get, I mean, we saw some questions in the previous term paper, sir. It's saying for the outer join, we use on the attributes. Like we have to use the on. I mean, where is not, where is incorrect, where option. Is it
So
like
like,
that?
so suppose if the attributes are
Because
same in the
see this is the
yes, sir.
natural left. So you can if you are joining inner join, you can also on operator. You can see you can try out different things. You can so this is natural left outer join because course ID is matching. So you can say you can suppose there is it's only left outer join. You can see the select start from A left outer join B on whatever the attributes you want to match like that. You can see that according to the question it will
Sir,
okay.
if ultimately all values of A will be returned, then what is
Mhm.
the advantage of using it this one? Or use A instead of using left outer join?
You use
Use
yeah,
A, only A,
yeah.
instead of the doing this
Okay,
join.
so you want to know the what is the prerequisite ID also, right? We want to the from B, we want to the prerequisite ID also there. So that's why whatever the prerequisite ID. So that's why.
No, it's in this a graph, in the diagram.
Yeah.
The only A value of A is
So
highlighted.
yeah. So why is highlighted? Because you can see that whatever the attribute A is present in must be then all the tuple will be the present in the and then left outer join. That's why it is mathematical representation, graphical. So how how you see in the net left outer join, how you visualize. That's it.
Sir, just one question,
Okay, sir.
sir.
Yeah.
As you here, you select from A left outer join B with B,
Yeah.
and then you say the on operator you are giving some condition of joining,
Yeah,
where
on
this condition of joining is taking by default course ID.
yeah.
But if
See,
I yes,
see, no, you have to mention the attribute name if you are using the on operator. On, then you have to the mention the attribute name. This is the course ID. So if you natural left out, then you can know the natural join already out of the command attribute, it will automatically join. But if you using the on attribute, then you have to mention the which attributes you are join. So if you mention the course ID, so you have to mention the course ID.
no, so then in that case, what is the use of one operator when I can use
Okay,
this?
okay,
Because
okay, okay, okay. Suppose there are no, okay, okay. Suppose there are two table A's. Okay, so this is the like email ID. This is the student and the email ID and the name, right? And this is the faculty. Okay, this is the student name. Okay, okay. So let's write this is student name, and this is the email ID or faculty ID. Suppose this is the faculty ID, and this is the faculty name. Suppose we want to, you know, match the common name between the student and the faculty. Then you can see the student name and the faculty name. These are the two different things. So you have to mention. Then you can mention in the are equal to student name equal to uh, this student name equal to faculty name. But on operator use on which attributes? This suppose okay. This is sorry. So this is the name also. So on operator you can specify on which attribute. Okay, let me another. Okay, okay. Sorry. Let me
Hello.
another. Yeah,
Yeah.
sorry.
So in short, you can do that like say suppose if you have two tables, student one and student two. In student one we have email ID, and in student two we have only email. So in that case, natural join will not work, even though the tuples will be the same, but the attribute name is different, right? So in that case, you can do on operator like inner join on. So student one dot email ID equals to student two dot email. But if the attribute name is same, email underscore id in both the table, then in that case you can use the natural join. So natural join automatically join based on the common attribute, and
And inner join.
inner join we have to specify on which attribute we want to join. Even if the names are different, we can join. We can use the comparison operator also in that on clause.
Oh,
Okay,
yeah.
okay. Let me give one example. Suppose this is the manager, this is the name, and this is the team ID, right? And the date of birth of the manager, and this is the teams. So, and this is the team's name, and this is the team ID, right? And this is the right uh, playground name. So if you do natural join between the teams and the manager, it will you can see that this is the manager name, this is the team names. So based on the name and the team ID, what are the matches? But if you that in this case you have to condition, you have to specify on the which attribute you want to match. So in that case you want to match on the team
Team
ID attribute. That's why
or natural
this
join.
honor attribute is there. So I hope you got it.
Yeah, if you do natural join between
Sir,
managers and teams, it will result in an empty set because name from the team is not the manager, so we'll not get the common field for that, right?
no,
So
actually,
we need to specify.
in this
Yes.
kind of scenario, we generally use the sir, through the table name manager dot name and teams dot name. This will identify two separate tuples
No, no.
in two
You
different tables.
cannot use natural join in this case. What I'm saying.
No, no, here, nothing, then I
Yeah.
cannot.
So
Yeah,
in
Sir,
natural code,
in our lecture, sir, PPD sir has said that I mean, the inner join and natural join is the same thing. If we are using the natural word, then the attribute, the common attribute name will not be repeated. It will be one time only. So can we
yes, sir.
take that as a different?
see,
Yes,
yeah.
yes.
So see,
Yes,
if
Subhendu.
you, yeah, if you do natural join, so so suppose this is the suppose a manager name and this is the team name, right? So these are the two. If you do the natural joins of the manager and the teams, what are the attributes will be there, like manager name and the team ID and the DOB and the team name and the player ID. If you do the playground name, like if you do the this is case of natural join. But if you do the inner join or anything, what will happen? This is the manager name.
Team ID will repeat twice.
The team ID will be the repeated like that.
So,
DOB
sir, like join is natural join is what we are doing a Cartesian product, but there should be a condition.
inner join means there should be some condition on which
So for
attributes in a,
natural join also we take condition.
yeah, yeah,
I mean, join itself is a Cartesian
yeah,
product with a condition.
yeah, 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 yeah. So yeah, so every up to this is clear. Okay, okay. So we'll see the uh, view. So a view is a mechanism to
Excuse me, sir.
hide certain data. Yeah,
Sir, did you explain the
I did not got
self join?
your
Did you
voice is
explain
breaking. Yeah, self
self join?
joins. Oh, yeah, yeah, yeah. See self join join between the table in the between the same table. So join
Okay.
so suppose there is a table A. Join between the same table is called self join. Nothing like that. It is same join between the same table. Select star from A and A. It is a join between the same table. That's it, and nothing like that.
So we can take two instances of the table, right?
Yeah.
Two instances of
Oh yeah. Two
table.
instances of the same table. Yeah. Two
We-
instances of the same table.
So it
Yeah.
forms Cartesian product only, right? I
Yeah.
mean,
Cartesian product of
self
the
join with itself. Okay.
yes, yes. So yeah.
Okay.
Yeah. So a view is a provides mechanism to hide certain data from the view from of certain user, right? So this is called virtual element. So a view we can create view using the create view statement. Create view then as then the query, whatever the query. And the materializing view, it create the physical table containing all the tuple in the result of the query of defining the view. So you can create materialized view. So syntax is like create and the materialized view and the query, whatever the query, right? Then we have learned about the various types of integrity constants like not learn, primary key, unique, and the check. So not null, it will contain all the not null value. And the primary key, it consists of not null and the unique, right? And that unique will be the like all the all the tuples will be the unique. And the check, so check, this is the very important thing. Suppose uh, in check used to suppose check. So okay, let's example, let one example. So this is the suppose uh, this is the department name. So you want to check the mm, you know this department consists of okay, so let's check particular value is present in the or not. So you can uh, so let me give me one example. So well, suppose you want to create on table student. and this is the name, and this is the ID, primary key, and you want to, you know, you want to put those students who are age greater than 18, right? You can check this is the age int, and you can check age is greater than 18 or not. So you can put some condition in the check. So if it is less than 18, it will not, insert. If it is greater than 18, it will insert, like that. Then we have learned about the referential integrity and the on delete cascade, on update cascade, like that. Okay. Then we have learned
So
about
can
the.
you take an example of on delete cascade, sir?
Okay. See what do you mean by on delete cascade?
Yeah.
Okay. So this is the instructor table, and this is the department table, right? You can see that this is the foreign key of, and this is the primary key of department table. So
Yes, sir.
this is the parent table, right? So if you delete, on delete cascade means if you delete biology department, if you delete this department, right? So what happened? Automatically deleted this biology. What in department name equal to biology, it will automatically deleted this department.
Okay, so
Or automatically deleted 10 rows.
by
This
deleting
is
the
known as on
primary,
delete cascade.
by deleting the primary
Yeah.
key, the other relation is also affected, which has the same attribute. I
Yeah,
mean,
yeah,
same tuple
yeah,
like biology.
yeah. This is
Only
called
the
on delete
biology
cascade.
ones will be repeated. Sorry,
Deleted.
deleted. Okay.
Yeah, what about the, it will check this is biology or not, this is biology or not, this is biology, it will automatically delete it, like that.
Okay.
This is called on delete cascade. Okay. Then the built-in data types like.
Sir, what about the one update cascade?
Okay, so if you on update cascade, if it is deleted, suppose on update cascade, if you want to set null, so it will automatically in this position it will be null. On update set null.
So what is syntax of this thing, sir?
So you can see that uh, on I'm not
Update
remembering, but I
cascade.
think on update
I
on
mean,
update cascade, I think you can see also set null, I think like that. And if you want to write set abcd or set anything, so like maximum time set null, so you can, it will automatically
so instead of biology, our
set
setting
null.
is to null.
Yeah, null. Yeah, like that. Yes, like that.
Okay.
So then the built-in data type like date, timestamp, and the index creation, how to create index, and we'll learn about the weekend about the index creation and the user defined data how to create, your in your own data types. Then the domain, how to create domain, and the authorization, how to, give access, grant, and the revoke, how to give, some authorization, read authorization, update authorization, and the delete authorization. And if you want to revoke the authorization, so you can revoke. And we want to how to create role, how to create role. And suppose you want to create role instructor, suppose instructor has insert and the delete and the update, so you can create role, you can set the authorization or set the what are the read authorization or whatever the authorization, like that. And the module 15 we have learned about the SQL function, how to create function, like that. And then we have learned about the also table evaluate function, how to, if this table evaluate function return a relation as a result. So a function and the procedure we have, if you have any doubt, we can, I've explained in the week 3 open session, we can also watch the same session. I've also taken on example how to create trigger, what is trigger, and how actually trigger works. So you can see also
Week
that
3
session.
open
Then the
session.
SQL procedure, yeah, week 3 open session, I think. Week 3 option. Then we have learned about the trigger. So trigger is a set of action that are performed in response of insert, update, or delete, basically event. Then we have also learned about before trigger, then the after trigger, then the row level trigger, statement level trigger, then the triggering event. So triggering event can be insert, delete or the update, like that. Okay, so if you have any doubt in week 3, you can ask, or otherwise we can go to week 4.
Sir, we had a
Yes.
yeah. Um, 1 second, sir.
Okay.
Hello.
Yeah.
Yeah, sir. We actually had doubt in question. It was saying that uh, the query was like select star from employee
Yeah.
where name like underscore percentage underscore
Okay, let me
and
write.
can you please write, sir?
Okay. Select start from employee
Star from employee where name like
where name like
underscore percentage
underscore percentage underscore
and name like
and and name like
underscore percentage
underscore
Aman, I have
underscore.
put that in the chat window also, so
Yeah.
so you can refer.
Yeah. So
so you can
we'll discuss. You can put in the chat window and we'll
I
discuss
have put it in the chat window.
Yeah, we'll discuss after the week 4.
Okay.
Anjana, you can take.
you will discuss after week 4, sir.
We'll discuss after week 4.
Okay.
Yeah, actually, Subhendu, you can take week 2 and week 3 doubts now, and then we'll directly like start from week 4 itself. Yeah.
Okay.
Yeah, so can you look at the chat,
Yeah.
please?
So chat chat window is not there anything. Okay, let's see. Okay, yeah. What is the doubt?
Yeah, so sir, in that answer was coming as last option, NKN. I am not getting how it is being evaluated.
Yeah, actually, even I checked it in PG admin as well, recreated the thing, but I'm getting all the 4 selected, not only NK.
Okay.
So
So
I got
I think this is
confused.
the activity question, right?
So
Hello?
yes,
I
sir.
think
But
someone was having a doubt, so I just
Okay.
checked
So
that.
can you tell which activity? I think.
I'm not sure because I got that problem from someone else. So
Okay. So yeah. So I will. Okay. Let's see the which activity question
I
will.
think it's week 2 only.
yeah, must be
Yeah.
week 2 somewhere.
Okay. Let's see. Okay. Select start from.
Start from EMP.
Yeah. I'm writing.
Okay, I thought I thought you need assistance. So I just
No. Where name like percentage and there is a space, right? There is a space.
oh, it's a space in between the
Yeah.
percent. Oh, okay. Then I understand. Oh, it's
Okay.
because of that. Okay, got it.
Sir, but
I
go
So
ahead,
was
sir. Go ahead.
percentage underscore percentage.
Please explain, sir. Go ahead, sir.
and name like one character, then after that one space, then this. I I think in you can solve because a space is missing. So you can solve.
Yes, sir.
Yeah. So there is a I think there is a 4 option. So I will quickly go through. A Roy, I think. then mega S, then R R Chaudhary, right? Chaudhary. Then there is a N K N. So you can see that A Roy, because you know you can see that after the space there should be one character. So this will be not matches. This is message mega S, but you can see that uh, first one is the should be the one character. So this is not matches, but you can see that R R Chaudhary. So after the space, this is, there should be one character. This is not matches, but you can see that NKN. This is matches because N K. Then after the space is one character. You can see that this also matches N K. Then you can this is matches both the both the string operation. That's why this is the correct answer.
Yeah, thank
Sir,
you, sir. Actually, I missed that space, so I didn't understand because of that.
Okay. Oh yeah.
sir,
Sir,
the
here.
space in
Sir,
between the underscore.
Yeah. Okay.
Sir,
Let me share on.
please can you go there? Actually, sir,
Yeah.
what are white spaces, sir? White spaces.
What spaces means
White
oh this
spaces.
is this is what spaces means. Suppose uh, uh, Ram Das, right? So this is the white space one after the first time. This is one white space. So this is the
Oh,
white space.
so is there in
So
between
that
white space in the
the white space means blank, nothing like that. Blank.
So basically, there should be a space in the name at second and second last position. That's why
Yeah.
it has
Yeah.
the last option is correct.
Yeah.
Sir, sir, does it consider the complete string? I mean, after the in the first one, okay, the percentage is there, right? Then space and yeah, in the first one, yeah. So space and one digit space is there.
Yeah.
So
So
in this, okay, so does it consider only we should get only the one particular space and any character or any string can come
yeah.
over there?
Last in the last character should be one. After the space, character should be one. Only one.
Only one character.
Yeah.
Well, one
Only one.
dash means one character only, right?
Yeah. Only one character. This means.
Okay. And before that, sir, what does it mean by before? Like anything can come.
Yeah. Anything can come.
Entire string can come.
One
Uh-huh.
character should become. Then after that, anything can come
Okay. Okay.
like that. So I think everyone got it.
okay, sir.
Yeah. Okay. Anjana, you can take.
Yeah, sure. Let me share my screen. So is my screen visible?
Yes, ma'am.
Okay. So in week 4, basically we have started with non-formal and formal, non-procedural and procedural query language. So procedural query language was the one where the how we need to get a data and what data we need to get is mentioned. However, in non-procedural query language, what happens? We are just mentioned what we need to get, what is the result that we should achieve, but how it should be achieved is not mentioned. So that is the difference between procedural and non-procedural query language. Then in module 16 we have discussed some operators, which were select operator, project operator, union, set difference, Cartesian product, and rename. We have also discussed about division operator. So say for example, so okay, I'd like to ask you all. So say for example, we have A and B. This is a table A, and then we have alpha, beta, alpha, alpha, and beta, alpha. And we have another table as B, where we have B as alpha and beta. Now, if we perform the division operator on this, would anybody like to give me the result? What would be the result?
Alpha.
Alpha, beta, and alpha, alpha.
Yeah.
Yes, ma'am.
Sorry?
No.
Alpha, beta, and alpha, alpha.
Only alpha.
Yeah, that's right.
Only
Only alpha, right?
only
Yeah,
alpha.
Oh, the second,
yeah,
oh, second column will not be mentioned. Okay, sorry.
yeah, because alpha beta is being satisfied by this particular tuple.
Right.
These tuple. However, beta has alpha. It does not have one more tuple as beta, right? In the B column. So that is why the answer will be alpha only. So it looks like division operator is clear to all of you, is it?
Yes.
Are anybody of you having any doubts in division operator?
No.
No,
No,
ma'am.
ma'am.
Okay, okay, okay. So in the 17th module, we have learned about relational algebra. I mean, we have learned about TRC, DRC, and the equivalence relational algebra TRC and DRC. So here again, we have these two tables. You might remember these from the earlier sessions that we took. So here what we need to find out is we need to find out the relational algebra TRC DRC expressions which will return the name of students along with sports whose marks are greater than 78 and who have won more than 2 awards. So would anybody like to volunteer for relational algebra? Yeah. Anyone? It will tell you also how much confident you are in relational algebra TRC and DRC.
Ma'am,
So
please explain,
yeah,
ma'am. RA, I don't know RA, ma'am. Please explain.
RA is relational
Mm.
algebra.
Yeah, I mean, how to derive these things, ma'am. That's what.
So, so do you remember the operators?
Yes.
Yes, ma'am.
Yeah.
Are you aware of the operators? Okay, so can you tell me what the select operator does?
It select the rows.
Yeah,
Rows and
yeah,
tuples.
yeah.
Yeah.
So basically, it will perform like a where clause, right?
Yeah.
Yeah. And what will the project operator do?
It
Columns.
will select columns.
Columns.
It will select columns. So basically, it will perform as the select clause in SQL, right?
Yeah.
So, okay, so now that we are asked to find out relational algebra, so what we will do, as you can see, whose marks are greater than 78, here we have some conditions given. So, in SQL, where do we put the conditions? In the where clause, right?
Yes, ma'am.
So,
Yeah.
that means here we need to put the conditions in the
Sigma.
sigma, right?
Correct.
So, what are conditions? The conditions are marks should be greater than 78 and who have won awards more than 2, right? So
Yeah.
uh, our conditions are
Sigma
marks greater than
78.
78, and since you can see here we have written and, then we need to perform the and operator, who have won awards more who have won more than 2 awards. So it is from this particular attribute, so it will be
More
awards
than 2.
greater than 2. Excuse me for the handwriting.
Ma'am, one query
Yeah.
over here. When we are writing only names of the students, why not projection? Why sigma?
No, no, no. That, yeah, that we are doing right now. I'm just writing down the condition. Okay.
Okay,
This is
okay,
the condition. Yeah.
okay.
So, okay. So what we need to, okay, I should have once line by line. I'm sorry. Okay. So at first, what are we asked to return? We are asked to return the name of students along with the sports, right? So we will use the project operator. Then we'll use the name and sports. Here you can see sports. So we'll write sports. Then in the bracket, as we have taken the marks greater than 78 and awards greater than 2, and then we have to like perform join between these two tables as well, right? So what we will do, student natural join activity. Activity. So is it clear? Relational algebra?
Yes, ma'am. Ma'am,
Yeah.
one doubt, like like we have to specify the name attribute, like which table it's belong to, like either t dot name or like s dot name, something like it's a common attribute within the
Yeah,
in the both table.
yeah,
So
that's right. So basically, what will happen? Since we are performing a condition, right, and we are performing natural join, so it will take out only those names which satisfies the given conditions. So you
okay,
don't really need to write t dot name or s dot name or whatever.
but ma'am,
Yeah.
in the tuple which will be returned by this sigma operation
Hmm.
will have two attributes containing name, like two same attributes.
Is it? Are you sure?
Yeah,
Okay.
like
So let's check here. Okay. So we need marks that are greater than 78. So David and Anand, right? From this particular condition, David and Anand will be selected. Now our next condition is awards greater than 2. So greater than 2 would be
ma'am,
Matthew.
I
Yeah,
got it. We are performing natural join, so it won't return two common attributes.
yeah, that's
They
right.
will be single. Yeah.
Yeah. So basically, it will since we are performing the AND operator, it will take the one that is common that satisfies both the condition. So here, if you can see that Anand is satisfying both the conditions, right?
Ma'am, if name of these no common columns are not there, so will it return all the records or null record it will return?
If no common attributes, I
Yeah,
mean no common
correct.
tuples are there.
Yeah. I mean,
Okay.
suppose we have name here in this example, the two tables are there, right? So name is a
Yeah.
column which is common
Hmm.
into both the tables.
Okay.
If we don't have the name in the second table,
Hmm.
okay.
Hmm.
So will that natural join return null set?
Yeah.
It will return a cross join, right? If there are no common attributes, then there will be a cross join will be performed.
That's actually my question, ma'am. I got confused in this thing. Suppose I remove the name column from the second table.
Okay.
So how many records will it return? I mean, it will perform that cross join or natural join or null set, sir. That's my
Okay, so if the name attribute is not there in the another table, will it perform a join?
No.
No.
Exactly. It won't
No,
perform a join, right? Because there are
no.
no common attributes.
No, no, that's what he is
Since
asking.
there are no,
His question is, if it is not there, then what
yeah.
is the value it returns? Is it error?
I think it will cross
Uh,
join. Yeah.
It will perform the cross join.
Hmm.
So in that case, it will bring all the records, right?
Yeah. So 4 into
I mean,
4, 16 record you will get. Yeah.
exactly. Yeah, that's the. Ma'am, can you confirm this thing? Is it right?
Yeah, that's right. Yeah.
no,
Okay.
no, no, no. It's a clarification. If you don't have the name in the second table, still we perform cross join.
If we don't have the name in the second table, yeah, we can do that. Cross join will work.
Cross join is possible.
Other
Okay,
joins
good
are
math.
not possible. Cross join is possible.
Cross join is
Hmm.
simply a multiplication of two tables, matrix multiplication, you can say.
If name is not there in the second table, then natural join is not possible.
Yeah.
Yeah.
So in this case, as we are performing the natural join,
Common attribute
it will be a
requires to be
blank
there
set.
in remaining joins, no? And
No, no. If you
this
in
join
the,
it is not.
my question is sometime back you were showing cross join as per the set theory it is an intersection, is it? If you show in the set theory notation, cross join is an
That
intersection
was inner
between
join,
two sets.
not cross join.
No, 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 not cross join. Cross join is not
Cross join.
intersection.
Yeah, inner join is intersection.
So how do we read depict in the set theory? It's a union, is it?
Cross join is
Yeah.
basically a Cartesian product.
Yeah.
So it is neither union nor intersection.
Yeah.
It's all possible combinations.
Of all
Okay,
that.
David will be connected with all the 6. David will be connected with all the 6 lines, is it? Like table 1, David will be connected to all the 6
All the 4
lines
records.
of the table.
Yeah, yeah.
Yes, for each
Okay,
row
so
of the
it is just a
table will be
multiple.
having, yes.
Okay.
So you will get 16 rows here. For each row with the combination of 4 rows, right? On the table.
25 rows, is it?
Uh-huh. Yeah,
16.
25. No, okay.
25.
5 5. Okay.
5
5
5.
5.
25.
25.
Yeah,
5
yeah.
5. 25 row. Sorry. So now another question, like if suppose the in the second table we have something else instead of name, like full name. So now
Okay.
if you want to represent using RA, relational algebra, so how can we do that? So it is like full name in the second table activity.
Okay.
Then do we have to mention the on condition as we write during the SQL? How to do that? Is it possible to write it in RA?
Can we do like Cartesian product and mention that it
Yes, yes.
Yes.
student dot name is equals to
Like
activity
two.
dot name
Yeah,
is like
what
that?
we
Yep.
are.
Can do.
Yep.
Yeah.
Okay.
Okay.
Okay. Okay. So now we'll move to TRC. So would anybody like to volunteer?
Yes, ma'am. Me.
Yeah, please go ahead.
Okay. So there will be T's
Okay. T.
such that there exists
There exists
P belongs
P.
to student.
Okay. Belongs to students.
There exists A
A
belongs to activity,
belongs to activity.
where in the parentheses we will write like P dot name
P dot name.
is equals to T dot name,
Okay.
and uh, like marks. Okay, so P dot marks is greater than 78,
P dot marks is greater than 78.
and A dot award is greater than 2,
A dot award
is greater than 2,
is greater than 2.
and like one more thing which I'm missing, like we
Yeah.
have to mention one more tuple with the,
Yeah.
at the first, which will return the like corresponding sports. So
P
for
dot
that,
sports equal to A
Sorry.
dot P dot sport equal to A
yeah,
dot.
C dot sport
P dot sports equals to A dot sports.
sports, yeah.
Yeah.
But we can't write like P dot sports. We have to select something like at
T
the,
dot name it should be.
yeah, no, no,
T dot
I
name
think,
equal to A dot name actually.
no,
No, T
at
will
the
be having
beginning,
sports, so it will be T dot sports equal to A dot sports.
Yes.
T,
Yeah.
what you are getting as the
T,
output, it will
no,
have.
at the
T
But
position of
the
name.
we are
natural join
using
is
T.
on name now, so
At
it
the
shouldn't
position
be
of T,
name.
No,
let me
both
clear it.
things they need name and sport.
Like at the position,
Project on both.
at the position of T, we can give an extra attribute, call it as, like T comma as at the beginning map.
No, but we do not have sports in students, so how can we write P dot sports?
Exactly. That's why I'm
No.
saying that
It will
it
be
should
T
be T
That's
dot
why I
name
had
equal
to
No,
to
we
A dot
mention
can't
it.
write.
name.
Like
Not
Not
it's
T,
okay.
P dot
comma
sports.
Okay.
as,
Okay.
T dot
Okay.
ma'am,
Just
ma'am, T comma
Yeah,
as
ma'am.
at the
Please,
beginning.
can you?
okay. Yeah.
T comma as at the beginning.
You cannot
T
write
T
T comma
comma.
S.
No, you cannot write it that way.
No, that is wrong.
That's wrong. Yeah. Okay, so let me clear your doubt. So instead of P dot sports, P dot how we can write P dot sports we can't write because P belongs to students and sports is not an attribute of students, right? So we can write it down as A dot sports equals to T dot sports. Is it clear?
No, ma'am. Please explain, ma'am.
Ma'am, in this case,
Yeah.
shouldn't we look at the common attribute in two entities at all?
Yeah. That also we need to do that. So what
Okay,
we will
okay.
do? P dot name equals to A dot name.
Okay.
So
In this case, even I can give T dot name also, na? Instead of P dot name, I can also give T dot name,
no,
right?
no. That we have done here, right? P dot name equals to T dot name. So look,
Yeah, but I
in
mean,
order
why
to
why can't we give that? Why can't we give that?
here
Because
we
A
have to perform the join. We have to perform the join as well, right? Between the two tables.
right. So
So if we take T
if I
dot name,
mention if I so I'm just
hmm,
asking if I mention here T dot name
yeah,
equal to A dot name, still it will be a join, na? Because the
okay.
condition will perform the join, right?
Yes, yes.
No. It won't be a join. T is a join. the tuple, right? We are taking p, like there exists p that belongs to students. Then how will that be a like? We need to like we need to join these only.
Right.
We'll have to
So
take
this
in order to
student and
get
activity
the
is to tell
So
this
basically,
t
T
dot
is
name
the
equal
out.
to a dot name is basically ensuring the natural join between these two tables.
exactly. Yeah, that's
And
I
then you
mean,
are
I
doing
was
the
thinking
query.
A
Yeah.
equal to B equal to C,
yeah.
so A equal to C. I thought that way, so it can happen. So that's why I asked.
No, no. This is a is a
Okay.
different representation
So
of TRC. Yeah, you cannot consider that.
Okay, okay, thank you.
okay. So here basically what we are doing in order to get the get the name of the students and the sports, what we need to do is we need to perform we need to use this like say for example at first we need to get the name of students, right? So we'll get p dot name equals to t dot name, and in order to get the sports we'll take, since sports is from activity table, so we'll take a dot sports equal to t dot sports. So what these two conditions will do, it will project the name of the students and along with the sports. Okay, now we have to fulfill these conditions. So p dot marks equals to, greater than 78 and a dot awards greater than 2 will will satisfy the condition. And then finally in order to perform the join between the two tables, we need to perform, we need to write it as p dot name equals to a dot name, because these are the common attributes in both the table. So is it clear? Would anybody
Yes,
like to try another approach?
Ma'am, we should write
Another
a a dot name equals to t
yeah.
dot name as well, na? Ma'am, a dot name equals to t dot name. We should write that as well, na?
because ma'am, for example, if I take David, okay, so T dot name is also David now. A dot name is and we are actually, if we compare P dot name equal to A dot name, instead of if I keep T dot name equal to A dot name, ultimately it will be David, right? So it should work, right? I mean, unless there is some specific thing
So,
we should
Yeah,
not
yeah.
write.
Yeah. Instead of p dot name, you can take a dot.
A dot name also. Yeah.
Yeah. So instead of p dot name,
No,
you
no,
can
no, not over
also
there,
use
not over
a
there.
dot.
I'm asking about the last one. Here instead of P dot name, can I write T dot name?
Yeah. So the last one is basically performing the join operation.
No, I can't.
Yeah.
Okay.
The last one
Okay,
is
fine.
performing the join
That is
operation.
not possible.
Yeah.
Okay, understood.
So it
Also,
is not
there
possible.
should be something which is there in both the tables, and I have to explicitly write that. Okay, got it.
Common.
Thank you.
Yeah.
Okay,
Yeah. That is how you join two tables, right?
right. I thought that I can use
So
that
would
also, but good. I was not aware of it. Thank you.
yeah, okay, no issues. Okay. So would anybody like to try another approach? I'll
Yes, so
just
we can
clear
write
it
t
out.
dot name comma t dot sports in the beginning and
Okay,
remove. Yeah,
just a minute. Let me. Yeah. Now you can tell. Yeah.
so we can start with
So what
t dot
were you
name
saying? Okay.
comma t dot sports.
T dot sports.
No, something else other than T.
No, that won't. Yeah. Yeah.
Okay.
That's right. Okay. Say for example, we take it as a dot sports. Okay. Then yeah. Please proceed. There exists. Okay. There exists T, since we are taking T here. Okay. So there exists T that belongs to students,
And
and there exists A
belongs to.
that belongs to activity. Okay. So would anybody like to state the conditions?
Yeah, like T
Yeah.
dot
Please go ahead.
T dot T dot marks is more than 78,
T dot marks is more than 78.
and A dot award
Hmm.
is more than 2.
A dot awards is more than 2. Okay.
And T dot name is equals to P A dot name.
That's right. T dot name equals to A dot
Name.
name. Yeah. So that is another approach of TRC. You can either write it down in that manner or you can also write it down in this manner also. Both of
Ma'am,
them
one
are.
doubt here.
Yeah. Yeah. Please go ahead.
Ma'am, is there we have to follow any order to give the conditions in the TRC?
No,
Like,
no, 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 no,
or we can
no.
give it like in the question it's saying is marks
Hmm.
greater than 78 and awards more than
Yeah.
2. If we write first
That's
the
right.
awards are more than 2 and
Awards? Yeah,
then
yeah, yeah.
marks,
Bo-
so we
both
don't
of
have
them
to
will work.
follow any
No,
order
you
of.
don't have to worry about the order. Yeah.
Okay.
You can write it in any order.
Ma'am, second approach
Okay.
is more convenient actually. Is it
Yeah.
not?
Yeah, that's right.
First one is still
Yeah, so
confusing.
you can, yeah, you can choose any approach you like.
But ma'am,
Both of them will
but
work.
if we get the option of choosing option, and we get the
Hmm.
first one, okay, whatever you shown earlier, so I
Yeah.
think we can be confused. How so we get
Yeah.
this kind of format?
So look, when we are using this T dot name and A dot sports, right? What are the conditions that we are not using? There are only two conditions that we are not using, right? That is T dot name equals to say S dot name and A dot sports equals to T dot sports, right? So if there is just T, then you need to make sure that the columns or the attributes that we need to achieve uh, shall be written in the conditions area. That's that. It's not much of a difference. Just yeah,
We are just creating the alias for that.
yeah.
If I want to use some other name,
Hmm.
some other tuple, say K, A, B, C, whatever, what
Hmm.
is the value that A or K that tuple takes, that I define under the condition that T dot name equal to the K dot name and
Okay, that is DRC
yeah,
actually. Yeah, yeah. So in TRC, like there is not much of a difference. Just you need to make sure that if it's just T, then the attributes that needs to be fetched are also mentioned in the conditions column, conditions area. Is it okay? Okay.
Yes, ma'am.
So yeah. Okay. So we'll move to DRC then. Would anybody like to volunteer for DRC? Yeah,
I,
anyone?
I can try, ma'am, but I'm not sure.
Yeah, yeah, sure.
Yeah.
Yeah, not an issue. Yeah. Please go ahead.
So,
You want me to name these attributes?
uh, yeah, like
Okay. So for simplification, we'll take A, B, C, D, E, F, G, and H. Okay. Yeah. You can
so,
move.
so we'll start as angular bracket A,
Yeah. Hmm.
and
E, E. Sorry,
no, no, F,
F. Yeah, correct.
Okay.
A and
Yeah.
F,
Yeah, that's right.
such that
Okay.
mm, such that A
Ma'am, C
is
exist and
There
G
exists
exist.
C and G.
Yes,
Okay.
ma'am.
At first, we need to take for a single table, if you remember.
yeah,
Yeah. Okay.
like so.
Hmm.
Uh,
Yeah. Please go ahead. Whatever comes in your head.
okay,
Hmm.
so we will take as angular bracket
Okay. So there exists.
C
Okay.
and G.
But we will have to take at first for one table, right? So we'll take G afterwards. Okay.
Okay, ma'am.
So we'll take C, then yeah. Please go ahead.
uh, then after like C sorry
Remember, you have to take all the attributes that belong to a particular table. So we'll take A,
A
B, C, and D. Re- Please remember all the attributes, okay,
Okay, ma'am.
that belongs to
Friends.
students. Okay, then
then same as like there exists
You
Here marks,
y-
ma'am. Here
yes,
marks we have to put na.
yes,
Yeah,
very good. Yeah.
and marks is greater than like
No,
78.
no, 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 not marks. What
Yeah,
are we considering marks as?
C.
yeah. See, I mean, sorry, yes, ma'am.
Yeah, very good.
Greater
That
than
thing.
C
78.
greater than 78. Okay. So now we'll move to another table. So what we should do?
Natural join as well.
Okay. So we'll do and there exists. What
F.
will be in there exists?
Sorry, G.
Okay. G. Then
Uh,
All the column, ma'am. All the columns.
exactly,
E F
exactly.
G
E F
G H.
G H belongs to
Activity table.
activity.
Okay.
Hmm.
Here and
Okay.
awards. I mean G greater
Yeah.
than 2.
Okay. Is any other condition left out, or are we done?
Name. Anything?
Yeah, you need to perform the join, right? Yeah.
Yeah, the name join.
So what shall we do? And A equals to E.
To E.
Yeah, that's right.
Equal to E.
So finally we are performing the join as well. So this is how we do a TSC. So is it clear to all?
Yes, ma'am.
Okay.
Ma'am, can you explain once
Yeah.
again, sir? DRC. So
Okay.
these, ma'am, these are the domain names A, B, C, D.
Yeah, that's right. For all the attributes. So
Okay.
basically, for name and sports, we have the domain names as A and F, right? So we'll specify them in angular brackets. Then such that, so at first we'll take one table and then we'll move to another table. So in there exists, remember, we can write A, B, C, D, or we can write B, C, D, or we can write C, D. But remember one thing, the condition that you are about to specify, that is the column that is used in the condition part should be mentioned in the there exists part. So here, whose marks are greater than 78, right? So we are considering the C attribute, that is the marks attribute. So we need to write there exists C. It could be A,
So,
B,
ma'am,
C, D, it could be B, C, D, or even if you use just C, it will work. But you have
so
to
ma'am,
use
we
C.
have to use it in the beginning only. There
Yeah,
exists C.
there exists C. Yeah, there exists C. Then we'll begin the parenthesis. Then again, in the angular bracket, we'll specify all the attributes that belong to that particular table. Okay. So A, B,
Ma'am,
C. Yeah.
ma'am, we can remove their exit symbol. Like
No, 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 no,
we can
no.
need,
We can't.
ma'am. We can I can like. Can you write like I can write the query again?
You can
Okay.
Like
remove that.
what?
Okay. Yeah,
Let
yeah, yeah.
what you can do,
Okay. Yeah.
ma'am. Can you write a new query?
Yeah. Please tell.
Yeah. So angular bracket A
Okay.
and F.
Okay.
Yeah. Such that
Mm.
uh, A B C D belongs to
In
S
angular, right?
angular. Yeah, in angular
A, B, C, D,
belongs to S.
S, or students.
S. Yeah, S for student and
S or students.
S.
Student, you can
So
say.
where are you specifying students as S?
Okay. So then you we should write student.
Yeah, students.
Students
Hmm.
and
Okay.
angular bracket E F G H
E
within angular
F G H.
belongs to activity.
Okay.
And one more thing we can mention, and
Hmm.
uh, student square bracket students square bracket C close square bracket greater than 78 and activity square bracket G is greater than 2. That's all.
Okay. Okay. So I think you have gone through internet, or
No,
so
no,
we
no.
specify.
I just read
Okay.
read on the slides.
of the lectures. So
Okay.
there's something mentioned something like natural join. So that's why I was
Mm-hmm.
trying this way.
No, no,
Okay.
no. So
Yes.
no, no. In
I
this way,
don't think.
you cannot do
Ma'am,
that.
here also the name is not
Mm.
the comparison is not done, right?
Yeah, yeah. The join
Join
is
is not
not
there,
found
ma'am.
Hmm.
here.
And
Mm.
also, you are not using what is C here and G. Okay, so you are in angle bracket dimension, but this is not a general convention we are following.
Mm-hmm.
So if you
Okay.
have referred to any external resources, so whatever the
Yeah.
standard we are following, notation we are following in this course, we'll stick to that, not
Yeah.
any other notation.
But ma'am, in the lecture slides, like I can see something like this.
So,
So that is different one. That is for TRC. I know that is for
No, no,
TRC, but
it's domain calculus, not for tuple relation calculus.
we are not mentioning the that thing here. That is a different thing. You can see that you can compare this to query in the slide. That is different one.
Ma'am, I have one question here in the same thing only.
yeah.
No, no, no.
Okay.
What here he has followed all the conventions and notations. Only thing is what he has missed is the relations. No,
Join.
otherwise it is. Is it wrong anything in the way what he is initiated?
See, the convention we are following in this course, we are not using student and in the bracket C and then greater than that particular condition. So we are not following that because if you see the concept of DRC, so why we are repeating the students writing again and again, right? So we can simply use the there exists C and which belong to that particular student table, and simply we can mention the
Ah,
condition.
okay. So he's
Okay,
Why?
so
repeating
Yeah,
it. Okay.
okay, at the beginning we'll have to consider an alias, something
yeah,
like
yeah.
there exists.
So
Yeah.
TRC and DRC is a non-procedural query language. So we try to make it simpler, right? So why we are making it complex by writing the students again and again, right?
Oh,
Got
Yeah,
it. Got it.
yeah.
Thank you.
So what you can do is instead of following that particular condition, that particular roach, you can follow this one only. It will be much more simpler to do,
Yeah.
right?
yes, ma'am.
Okay. So DRC, relational algebra, are these all okay to all of them?
But the
I've
that DRC that you have
out.
written in the
Yeah.
body, do you use
Yeah.
intermediate first bracket or it's not required?
This one?
Yes, this one, and after that first statement that exists C, all this first bracket is required or we
Yeah.
can remove?
No, it's required because there exists C belongs to students only, right? So you need to specify.
Then,
We are not.
then in the second statement, there exists G, that is
Yeah.
also needed one first bracket prior to this and
Yeah.
statement A equal to E.
Yes, yes, yes. C, both at the both places. Like there exists C and C is more than 78.
After G greater than 2, there shall be a first bracket close.
Ma'am, but
No, no,
here
no,
my
no. You
same
don't
question.
need to do that. Yeah.
Ma'am, when we already have mentioned, okay, in the brackets, okay, A, B, C,
Hmm.
D like that, okay, like
Hmm.
the exist A, B, C, D are there, has to be there
Okay.
in the student table.
Yeah.
Now, what is the point of writing C outside, ma'am? Exist C. Yeah, this
Be-
one.
because we are using this condition, right?
The same thing we have used inside also, ma'am, because A, B, C, D also has 2%, right? Has to exist in the student thing. So I think this is unnecessary, ma'am.
No.
Yeah, this is fine. Yeah, it's fine, but it's extra.
See, if you are using the that you are applying the condition particular attribute like we are applying on C, then in that case you have to mention there exists C.
Yes, sir, that's right.
Otherwise, it is not necessary. If you are not using C greater than 78, then no need to use that there exists C. But if you are applying the condition on that particular attribute, then you have to specify that
So, sir, you mean to say whatever condition we apply for a table student, I need to write down those column outside, kind of exist.
outside. There exists, yeah,
Yeah.
symbol.
Hmm.
Okay, and those has to be in the order.
No, no, not necessary. Only there exists C or comma A, B, anything you can do.
But here it should be in the
Yeah,
correct order.
here it should be in order. Yeah.
It should be in the same order, the way it
Yeah.
appears in the table level.
Yeah.
Yeah, that's right. A, B, C, D, E, F, G, H. You can't like remove change the order. Okay.
So you are
Okay,
specifying means
okay,
A stand for name, B stand for age, C stand for marks, like that, right?
okay.
And this AND condition A is equal to E, where the natural join is performing. This
performing. Yeah.
Outside the first bracket, or he has to be inside only?
You can mention outside the bracket also, no issue. This is non-poster query language, but looking at the that DAC, we should know like what data we have to get, right?
Hmm.
Yeah.
No, why I'm asking this question, this condition, because it is performing the natural join between the two tables. I can state this condition in the first C itself. There also I can write, right? Then
Like in the students
first
table.
in the student table also.
Yeah, but we have not specify what is E there, right?
That,
Before that,
no, you say that it is not following the order.
no
So
order
will
means
it
I'm not
matter?
taking. No, I am talking about the bracket. So if you are specifying E before, then you can do that. What A equals to E. But till then, once we read from left to right, we don't know what is E here, right?
Okay. Okay.
Yeah.
Ma'am, our doubt
Yeah.
on domain relational calculus, like it's belong to lecture slides. I've shared the question within the chat box.
Hello,
Can you
hello.
say, like, could you see it? Yes, ma'am.
Okay. So, sir, I guess this was the incorrect one,
I
right?
have answered it. Yeah, I have answered it on Discourse. Let me share that link. So if you see, we have to based on the condition, we can join that. If you read the hint, pilot must be certified for at least one range with sufficient large cruising range. So just go to the Discourse post for 5 minutes. I will get back to you if you don't get the answer. Yeah,
Okay.
yeah, I have shared the link. Yeah.
Ma'am, and can I also mention instead of this A, B, C, D, can I also mention the actual column names here, or I shouldn't?
You can do that. No
You
issue.
can do that, right? Okay,
Yeah.
thanks.
Yeah, then throughout you'll have to mention the
Right,
names only. Like if you are
right,
mentioning it, yeah.
right. Thank you.
Will you explain entity sets also in this week 4?
Yeah.
Okay.
Yeah, yeah, yes.
Is there any easy way to select all? Like we are using the star in the select query, no? We cannot use it here, is it? In the table, we have taken all the attributes, no?
Okay, so yeah.
Can you please repeat? I am not getting your.
What here we are A, B, C, D
Hmm.
means what we are taking almost all. Instead
Yeah,
of
all the
that one,
attributes.
yeah,
Hmm.
instead of that mentioning A, B, C, D, can we put star?
Star. No, no, no.
And that's
Here we
what
are
we use in the
representing.
second.
Yeah, this is not. Yeah, for in DRS you are saying that okay, so A belongs to name, B belongs to H, like that.
So, yeah, but it's easy that suppose in the question paper it comes with a name and you got to write everything. That's too long to contain in a query like this. Like
Yeah, so
relationship.
that's why we are use. Yeah, so that's why we
No,
are using ABCD and we are renaming that particular attribute name, na.
Yeah, but here it's easy. But suppose in the exam question paper, we don't have an option to write A, B, C, D. No? So we got to write the field domain names.
no, here we are assigning by setting.
Huh.
Here we are assigning. There,
Assigning is the way the student table has 4 attributes and the sequence of that attribute is A, B, C, D. I am using A. That means by this statement, I am basically telling the computer there is a table called student, there is an attribute called name. That attribute I am assigning henceforth as A. This is what
yeah,
I.
but
Hmm.
are we assigning in the code? We are not assigning in the code. We are just assigning it on the table. So we got to really do a separate activity for assignment. No.
No, no, this is like what TRC and DRC is used for. Say, suppose I don't know how to write SQL query, but I know TRC and DRC or relational algebra. So whatever the record I will write the expression in DRC, DRC or relational algebra, whatever I know, and I will give it to the SQL, like those who know the SQL. So they will convert this TRC, DRC into equivalent SQL query and give me the result.
No, that's a real world situation. But what I'm asking in the exam questions, how do we handle this one?
Like you can use any attribute, but you have to specify. You have to mention the same. We have to follow the same order. Instead of ABCD, you can use anything, X, Y, Z, anything you can use. We can use the whole attribute name also here.
Okay.
Sir, if we use the attribute name, say suppose there exists
Depends on you.
name, then no need to write this angular bracket ABCD, all this name. I can directly refer to
No,
that
no, no.
student table.
You have to mention all the attribute.
That,
In that case,
that's a question she ordered.
in
Yeah,
that case,
you
order
have to
matter.
order matter because it's DRC expression, right? So what if I mention age, comma, name, comma, marks, comma, subject? So age first.
Oh,
So what I will know, age belongs to the name, right? I can refer to that. This is not
right.
a general practice, right?
Okay.
Yeah,
So the order matters.
yeah. So just stick to whatever we have discussed for in this course. That's it. Only. Don't refer to any external resources.
Got it. Thank you.
Yeah, yeah. Thank you.
Yeah, so Sachin, have you gone through the post? Is it clear to you? Yeah, like I can read the hints and the queries. Like I'm not getting the solution. Maybe I have to write the queries on the Postgre as well. Then I may get the concept clear. I will look into this later. Like I can get the concept. I'm sure.
You can try it out and you can post it on Discord also.
Yeah, yeah.
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 Okay.
Okay. So TRC, DRC, is it clear to everyone?
Yes, ma'am.
Okay. So then in the module 18th, we have learned about design process, what is design, role of abstractions. Then this was the design approach, basically requirements analysis, where the data that needs to be analyzed for the user, which includes planning, system definition. Then we move to the other step, that is database designing, where we need to use a modeling framework to create abstraction of the real world. So it uses logical model, physical model, and then finally we head to implementation, where data conversion and loading happens, and finally the testing happens. So that was all that was done in module 18, and then we also learned about ER models. So ER model, which is basically used for mapping the real world enterprises into a conceptual schema. There were three basic concepts, which were attributes, entity sets, relationship sets. The attributes were of certain types. So the simple attribute basically means a simple attribute. Say, for example, it could be anything. Say it could be Aadhaar number. So Aadhaar number will have only the number itself, right? Then there were composite attributes. Composite attributes say name. So there could be a first name, there could be a middle name, and then there could be a last name. So that was composite attributes. Then we had single valued attribute, multi-valued attribute. So as given an example, phone number. A person can have more than one more than one phone number, right? So that is what was known as multi-valued attributes. Then we had derived attributes. So derived attributes, as the name suggests, it basically is derived from uh, uh, it can be computed from other attributes. So say for example, if Some we other attribute. specify the yeah, that's right. So so say for example, if we specify the age, then uh, the date of birth can be known by the age, right? Then we also learned about domain, a set of permitted values for each attribute. So then in module 19, we learned about different relationship sets with attributes, then certain cardinality constants, which were one to many to one, many to many, one to one. So basically, say for example, if we have an instructor uh, entity, and then we have, say for example, the relation as advisor, and then we have another entity, that is student. So if we go for one to many, then remember that for one we use an arrow, and for many we just simply will use a line. So if we have a one to many relation, that means one instructor should have every student should have at least one instructor. Okay. Then many to many means a number of instructors can have a number of students. Then many to many means many instructors can have one student. And then one to one means one instructor should have one student at least, one student only. Then we studied total and partial participation. So total participation basically means, say, instructor have total participation and teaches. That means that every instructor must have at least one student. That is total participation. And what partial participation basically means, that like participation of that particular or some entities may or may not be there. It does not really matter. So that is partial participation. Then we learned about ER module to relational schema. So how that was done is, so say for example, we have say, okay, so in the instructor table we have, say, IID as the primary key, and we have name, and then again in student we have SID as the primary key and the name. Okay, then this is an ER model, right? So in order to change it to relational schema, say we want to get the relational schema of advisor. Okay, would anybody like to tell what will be the attributes that will be there in the advisor table, advisor schema
CID
basically?
and SID.
Yeah, that's right. So basically the primary keys of the participating entity sets. So then finally, in the module 20, we learned about some extended ER features, which are non-binary relationship sets, which means that a relationship associating with more than two participating entities. Then we learned about cardinality constraints on ternary relationships. So ternary basically means three relationships, three entities associated with a relation. So basically, it would have caused confusion. So we outlawed the more than one arrow. Then we learned about specialization. So it was basically a top-down design approach where all the lower entity sets will inherit all the attributes and relationship participation of the higher level entity set. And it also includes overlapping and disjoint. So are all of you aware of overlapping and disjoint? Yeah. Am I audible?
Hello.
Is overlapping and disjoint clear to all?
Ma'am, can you please
Yes.
explain overlapping?
Okay. So overlapping, right? So say for example, we have person, and then we have two, like swimmer is another entity, and engineer is another entity. So what happens out here? A person can be a swimmer or an engineer, or a person can be both a swimmer as well as an engineer, right? So that is what is overlapping. Are you getting the point? Okay.
Ma'am,
So say for example,
this cross arrow is denoting
okay, yeah,
overlapping.
okay, no, it is denoting. Okay, so this is overlapping basically. Okay, so say for example, we have in an animal, we have, say, cheetah, and another animal as, say, cat. Okay, so uh, an animal can be a cheetah or a cat. Can an animal be both a cheetah or a cat? It can't be, right? So that is the disjoint. So are you getting the point? The difference between overlapping and disjoint?
Hmm.
Yes.
Yes.
Yes, ma'am.
Okay. So then we had to, yeah.
In the slide that the line you have drawn in the above,
Hmm.
that shows the disjoint.
Okay, sorry.
No, this is basically disjoints symbol. The bottom one is the overlapping symbol. I mean, as per slide, I am telling you. Yes, correct.
Okay. Then we studied about Okay. Then we studied about generalization. So basically, it's similar to specialization. Just instead of a top-down design approach, it follows a bottom-up design approach. It combines a number of entity sets that share the same feature into a higher level entity set. Here, like specialization, inheritance is not used. Okay. Then we learned about aggregation. So aggregation is nothing but representing relations within relations. Like relation sets can be available within other relation sets. So that is aggregation. Then
Can you give an example?
Ma'am.
Yeah.
okay. So, okay, just a minute. So we had an example. Okay, just a minute. I'll just take out this. Yeah. So this was one of the example that was given in the slides. So basically what happens here is a instructor, a student and a project, right? An instructor will guide the student for a project, right? And then the evaluation. So this is a relation. This overall is a relation, and inside this there is another relation. So that is aggregation.
So, ma'am, there is a ternary relation between instructor, project, and student,
Yeah, that's right.
and then there is a relation with evaluation, right?
Yeah, that's right.
So you can saying this whole is a relation. I mean,
Yeah, this whole is a
entity,
relation.
and inside that you
Have
this
another relation.
square bracket.
Yeah, that's
Oh,
right.
sorry, square. Okay.
Okay. So then we learned about a design issue, like what are the major points that we need to keep in head, and what are the like what we should use: the strong entity set, weak entity set, specialization, generalization, aggregation. So those were discussed, and then finally, yeah. So this is what happens in a one-to-one relation, many-to-one, the constraints basically. And then yeah, these are some of the symbols. So to represent an entity set, a square bracket is used. To represent a weak entity set, double square brackets are used. In order to represent a relationship type, a diamond shape is used, and identifying relationships type requires two diamond shapes. So these were the like for attributes. These are the symbols that needs to be used for multi-valued, for derived. Okay. So yeah. So yeah, anybody have any doubt in ER model? Yeah, diagram.
No, ma'am. Few mock questions if you can discuss.
Okay. So week 4 is clear. Are there mock questions on week 4 itself?
I don't know, maybe mix, but I have just some one or two doubts.
So from week 4, the mock questions.
I don't know, it is week 4 or week 2, but I had some street problems. Just a small clarification.
Okay. So
If you can go to the means problem number 5 of mock.
okay. So this is from
Yes,
week.
I do not know how to do this. Okay, but my only question is the kind of SQL query it is given here. So it is saying where P dot parts greater than 30, and it is asking for a Cartesian product between supplier and parts.
Right.
Now, this kind of table, my question is, I have to form this Cartesian table and then I choose this where condition to select. This is the normal procedure, but this is a very big table. Are we going to, is it possible, means within that time and so many columns? Means?
So if it is in the, if there will in the quiz, there will be a small table. Don't worry. There, this is the big table. So
Okay. Then, ma'am, go to the 13. Problem number 13. Here also, then I have to write all the entire X cross Y product and then I have to choose. Is there any other method that I can follow?
Like at first you have to find out the X cross Y only, right? That is how you'll be able
Yes.
to, yeah.
Then select B equal to C.
Right. And then you'll have to find
Then
out for this.
project it.
No, okay, that I know, means there is no alternative. If this table is a little big, then it is a problem. But as you said, it will be
No,
small
no,
table.
you don't need to worry about that. It won't be that big.
Okay, then last problem is problem 16. If you can discuss. 16, 1 6.
Yeah, Subhendu, would you like to take it?
yeah.
Okay, I'll stop presenting.
Okay. So let me share my screen.
Hello.
Yeah. Okay, 1 second. Okay, so okay, let me take a screenshot. Right. Okay, so okay, what is your doubt? Hello, am I audible, right?
Yes,
Yes.
yes.
Yeah. So
Yes,
what
sir.
is your doubt?
So this there is a 100 employee, right?
Yeah, 100
And
employee.
and we are doing means select star from employees full outer join with designation.
Yeah, designation. Okay.
In this full outer joint with this means it will create 100 tuples. This
No,
part
no.
I am not.
See,
Can you please clear this?
okay. So this is the employee. So let's take a small. This is the employee table. So this is employee ID, employee name, then department ID, and the designation ID, right? Designation ID. So let's take employee 5 tuple. So it will easy to understand. So employee ID, let's take 1 or 3 tuple. That will be better. 3 tuple. This is 2 and this is 3, right? Employee name like ABC. Department ID D0, D1, D2, like that. So and designation ID. So you have to find the maximum numbers of rows returned by the following query. So you have to, so when it will be maximum, when designation ID all will be the same, like designation ID is ds1, ds1 and ds1, right? And full auto join designation. So this is the designation table. Designation table ID, designation ID, designation name, and the salary, right? Let's take designation ID ds1, designation name like any associated, project associate, and salary is 30. Let's check ds2. This is project officer, and this is 40, like that, right? And ds3, senior project officer, and is 50, right? Okay, so we have to do
Sir,
the,
here one thing,
yeah,
sir. In the designation, if we
yeah,
keep one row where the designation ID is not present into the employee table, suppose DS7, you can say something else, something. I mean,
okay, this is
DS50,
ds7. Okay,
yeah, film something which is not available in the employee table, sir. That record.
okay, but you can see that this is the foreign key, right? It's taken from designation table. So
And
this is
also
not
not
possible.
constraint
Okay,
is
okay.
Yeah, this is not possible. So this is a foreign key. That's why I'm written ds1. So you got it?
Thank you. Yes, sir.
Okay. Okay. So when we join in full outer join, right? You have written full outer join. So how many tuples returns? We can see that full outer join, whatever the left tuple that will be there, and right tuple also. So this tuple also be there. This tuple also be there, and this tuple also be there. And we can see that these two tuple are not yet. DS1 is already there, but DS2 and DS3 is not there. So we can see that. So DS, then another tuple will be the DS2 and DS3. So how many tuple is there? 3 plus 4 plus 5. So total 5 tuple will be there, right?
explain once
Hello, you
again.
got it, or shall I?
Maximum
No, this
Yeah,
maximum.
full
no, sir.
outer join means
Example ID.
these 5 tuples are there, but some of the tuples in the left-hand parts will carry the null value.
Okay, yeah, yeah. So you can see that. Okay, let me. So in the uh, biggest case, so full outer join, what will be there? So
Full outer join is a simply cross join, no? I guess.
no, not cross join.
No, no.
So it's a
Employee ID.
full
Yeah,
it's a kind of a left outer plus right outer, right?
yeah,
Less
yeah,
inner.
yeah, yeah, yeah.
Yeah.
Employee ID. Then what are the tuple?
It means excluding common tuples.
Ah,
including common.
No, including cover, not excluding. Inner plus left outer plus right outer.
let me
Yes.
employee name. Then designation ID, department ID. Then designation ID. Then what will there? Designation ID, designation and salary. And the salary, right? So first employee ID, you can see that. Employee ID 1A D1 DS1, it matches with this, right? DS1, so it will print like that. Okay, you can here write there. Okay, we can write here, that will be better. Employee pull out a join designation, right? So what are the tuple will be there? First employee ID, then employee, then department ID, then designation ID. Sorry. Then designation ID, designation, and the salary, right? So first is employee ID 1 A D1 DS1, right? 1 A D1 DS1, and for DS1 you can see that it's matches, right? So DS1 it is 30,000, I think is 30. Sorry, designation is project associate, and it is 30, right? Simply you can say that 2 V D2 DS1 and DS1 project associate and 30. You can simply 3 designation is C D2 DS1, and this is, sorry, this is designation, and this is also DS1, and project is 30. Okay, right? You can see that DS2 and DS3 is not there. So what will be there? For output design, DS2 will be there. DS2, sorry, this will be DS2, and the designation is project officer, and 40, and DS3 will be also there, and senior something, I think, and this is 40, and this will be the null. This will be the, this also will be the null. So you can see that this also will be null, right? So how many tuple we get? 1 2 3 4 5. For you can see that if there is 3 employee and 3 designation ID, how tuple we get? 3 plus 3, and because of one common attribute we can get 1, so we can get 5 tuple, right? Up to this, is everyone clear?
Yes, sir.
So if there is 100 tuple, right, and 5 rows, okay, so 100 tuple, and you can see that 6 6 rows in means designation, so full auto join maximum rows can be possible because there can be one attribute in the command, right? So 100 plus 6 minus 1, so it will be 105. Okay, so everyone got it, how to this question? Hello?
Means you are taking one common out, right?
Yeah, because you
Minus
can
1.
see that consider all the attributes are having not null constant, right? So it cannot be not null. That's why you have to take one common attribute.
So if we remove this on clause in the
Yeah.
query,
Yeah.
then will it be lead to the same answer? No.
Uh,
Then in what basis these two get joined? And
yeah, it will see on designation at what are the attributes, what can be join will be what attribute, designation is the common, right? So that's it.
that means, sir, in outer join case, this on clause is kind of a necessary thing.
Yeah, that will be better, because if there is same name, then what basis should be joined? That may be confused, right? So in what attributes, what basis should be joined? That if you know, right, that will be better.
Sir, I'm confused about this designation 6 record site. So I understand from the 100 records are there in the employee. So
Yeah.
all the records will come.
Yeah.
Okay. And the because we have a outer join on the designation.
Yeah.
right? So all the columns, but they should be unique also, right? Isn't it like uh, the
So see,
column? Yeah, yeah.
see, if there are 100 employees, so all the designation IDs is the same, right? All the designation IDs. Okay. So see, suppose all the designation IDs, so 100 tuple will get, right? Sorry,
Sure.
100 tuple will get,
Yeah.
and you can see the one designation ID is common. Because of that, from that we'll get 5 tuple, because already one is, we have written, we have to write, because 5 tuple is left in the designation table. So because it's full outer join, we have to write also 5 tuple. So that's why we get 100 plus 5.
Okay. Okay, sir. Okay. Understood, sir.
Yeah.
So if it is not full, then only 100 tuples will get.
Yeah, if it is natural join, then it will be 100 tuple.
Not natural, not outer join
Oh,
only.
yeah, so not outer. If inner join, then it will get 100 tuple.
Sorry, in
Yeah.
okay. Thank you.
Yeah.
Sir, instead of maximum, if it was minimum, then
If it is minimum, then it will get, see, or you can mention that all the attributes are having not constant. In the minimum, then we get, so see, in the minimum, suppose, okay, let me think about it. Okay, so it's
Will
minimum,
be
right?
100 only, right?
Yeah, it will be 100, because, okay, let me explain. So if it is minimum, suppose this is ds2 and ds3. So how many tuple? We'll get only 3 tuple, right? Because all the tuple is in the left hand side is also there, and right hand side is also there. So in that case, minimum will be 100.
But sir, can we say this minimum, because you are drawing one condition where all the designation is present, but that may not be a condition, no? So can we define minimum like that?
So
Maximum I can understand, but
yeah,
minimum can we define like that?
minimum. So when it will be minimum? When all the, all the designation whatever is there is present in the designation ID, like the ds1, ds2, and ds3. So if you join, if you then pull out a join, what will get 1 a d1 and corresponding to
No,
be
no. If the
ds1.
table is like that, then what you are saying is correct.
Yeah,
But I
yeah.
am saying, how do you know this table is, the employee table is like that only?
So we
Yeah.
have to think when will be the maximum, when will be the minimum.
So you have to think in that way. When will you get the maximum number of rows and when will you get a minimum number of rows? Hmm.
Any other doubt?
Sachin is here.
Yes, sir.
Okay, so you didn't get that answer, right? Solution.
Yeah.
Okay, let me share this.
Hello, Piyush sir, you are not audible. Hello.
Yes, sir. Like we also can't hear Piyush, sir.
Okay, so I think some network issue.
Yeah.
Okay, so let's.
Sir, end term will be equivalent to mock quiz. Means sorry, quiz 1 will be equivalent to mock quiz.
See, see, uh, yeah. So all the question will be from slides and the lecture, so that I can explain.
That's
And sir, how many questions we can expect?
In the quiz one,
Yes, sir.
15,
Approx.
15 to 17 question you can.
Okay.
Yeah.
Sachin, right? Yeah.
Yes, sir.
Okay. My screen is visible, right?
Yes, yes, yeah.
Yeah. So here we have to find out the flight that can be piloted by every pilot whose salary is more than this particular number, right?
Yeah.
So what we have to find out the flight. So that we'll get from the flight number, right? So that is from flight table.
Okay.
But you can see here hint the pilot must be certified, right? In order to pilot, so piloted means it should be certified for at least one plane with sufficiently large cruising ship range. Okay. So the cruising range that is from aircraft cruising range must be greater than the distance that he's going to travel, right? So that is f dot distance. So this is a necessary condition that the pilot should have in order to certified, right? So this is the condition given to you. So your doubt is how we are joining these two table, right? So here you
Yeah.
can see, yeah. So f belongs to flight. There exists a belong to aircraft. There exists c belong to certified. There exists e belong to employee. So here you can see. Okay, we'll come back to that particular condition again. But a dot aid equals to c dot aid. So we are joining these two table, right? And here e dot aid equals to c dot aid, and we are joining these two table also, right? But in order to get this particular record, we need to join with this third table, right? From the other
Yeah.
attribute. So based on this condition here, you can see a dot cruising range greater than f dot distance. So if I want to join these two table f and a, what I will do? Select star from f means flight. Okay, then I will use inner join. Okay, so this is a DRC, sorry, DRC query. So f inner join a on. Now in the on class I can use comparison operator also. Here I can use
Yes.
comparison operator also. So here instead of on I will write a dot cruising range greater than f dot distance. This is equivalent SQL query for that.
So what it returns means like we'll have finally all the like this comparison
Yeah,
distance after distance is greater less than a dot crossing range. So like what it will return.
it will return the flight number. So
Okay.
we want to find out the flight that can be piloted by every pilot whose salary is more than the 100,000, right? So whose salary, the pilot that must be certified, and whose salary must be greater than 100,000. So that is also condition, right?
Yes, yes, yes.
Yeah. So that's why we need to join these two table, and for that applying this hint, we need to have aircraft table also for comparing the cruising range, right, with the
Yeah.
flight. So this is more little more complex one. That's why I've taken this fixed example. But in the quizzes and end term, you can expect simple where you can just perform the cross product on natural join.
Okay.
Yeah.
Yeah.
This is basically applying the on condition. Basically in relational algebra, I can say theta join is here. Okay. So I think in the one of the lecture, sir has explained about theta join. Not explain, just write down this notation
Theta
theta.
means
So
conditional
theta
join,
means
right?
in the conditional join. So here I can say a dot cruising range greater than f dot distance. This is theta join.
Okay.
Yeah,
Sir,
theta means
sir,
conditional join.
So in this way we can join like two tables on the basis of some condition.
Condition also, yeah. Here you can see f inner join a on this thing, right?
Yeah, that's why I was looking like there were no common attributes
Mm-hmm.
relations, so that's a bit confusing.
No, here you can see the distance is having say like we have to compare, right? So it is having the integer data type, and this is cruising range also having integer data type. That's why I
Yeah,
mentioned the hint, right? That is certainly sufficiently large cruising range. So basically, range is matter of distance only, right? Only the names is different.
yeah.
Yeah.
sir,
Okay, got it, sir. Thanks.
seeing the
Yes.
question, how we will able to figure out that whether it's a TRC question or DRC question?
No, we'll mention that. We have to write a TRC or DRC query for that
Okay.
in the question itself. Yeah. Or either you can also see from here, right? This is a different notation. But instead of I don't want to use, I want to use T here. So in that, at the last I have to use
That's
and T dot flight number equals to F dot F flight
so
number.
that TRC tuple relation calculus, right?
Yeah, this is TRC only. In DRC, you will get angular bracket, and you
Sir,
will get all the
sir,
attribute.
how these are different from SQL? So like TRC, DRC, and then SQL. Like
Not different. Like these are the equivalent terminologies we use. So this uh, TRC and DRC are non-procedural query language. Like if I don't know SQL, but I know this TRC and DRC, how to write the expression, I can write this expression and give it to the person who knows SQL. So he can convert this TRC equation to the equivalent SQL query.
so, like how they are interrelated with the TRC and based on TRC and DRC, SQL has been designed, or
No,
we
no,
write separately. Like three options are there. One can use SQL, one can use TRC, other can use DRC. Like this. Like
no. This,
how they are.
are you talking about design?
No, no,
So
like
that
whether there are three options available for a programmer, either to use
hmm.
SQL or to use TRC or to use DRC, or based on TRC and DRC, SQL has been different. How these three are interrelated? That's
No,
what
for
I'm trying to
programmer,
understand.
you have to use SQL only to get the data.
Okay.
This relational algebra TRC DRC, like if I don't know any SQL, I can, but I know this thing. I can simply write this expression, and it's your work to convert this into equivalent SQL query.
But we
These
cannot,
three are
we cannot use these two languages to fetch data, right?
No, no, you cannot use.
TRC and DRC.
these are
Uh,
only just for theory purpose, I guess.
Conceptual purpose, but the base of the
Yeah.
SQL is relational algebra.
okay, so based on these three, SQL has been developed, right?
Not relational algebra only.
Okay, based on relational algebra, SQL has been developed.
Yeah.
Hello,
Hello. Hi.
hello.
Yes.
Am I, am I
Yes.
audible,
Yes. You're
sir?
audible. Yes. You're
Yeah,
audible.
so
Yeah.
based on relational algebra, SQL has been developed, right?
Yeah. You
Sir,
can say
in
that.
ER diagram, yeah, sir, in ER diagram, we talk about total participation and partial participation, right?
Hmm.
So, like partial participation is single line and total participation is double line,
Double
right?
line. Yeah.
So if I am using double line, so how to figure it out that it's a one to query or many to query? How to figure out, sir?
For single line,
One
the arrow indicates one.
one dot. No, no. In lecture also, sir writes one dot dot one and star dot dot one. What was that? I mean,
Okay. Okay. So there are two
uh,
entity like this, and we have one
yeah.
relationship, and we have this line, right?
Yes.
Yeah. So this is, and in general, this is many to many. It is star to star, right? End to end.
N
We
two
can
N.
say, yeah.
Okay.
But if we have like this is arrow, and it is many to one. That is end to one.
Sir, for single line, it is clear like it is many to many. The first one is many to many, and the
Hmm.
second one is many to one, right?
See,
Hello.
double line indicates total participation, right?
A double line indicates total participation. In double line, how to figure out that whether it's a one or many? How to figure out whether that arrow will be provided?
Now, yellow will provide here instead of single line, it will double line an arrow like
Okay, so
this.
double
Yeah,
line and arrow means many to one participation, right?
yeah. But in this case, see this here only single line is double line, but difference is that this many to one, but it is at most one, right?
Yeah, at most one, right?
And here there should be at like one. So there should be one. It will not contain zero. Here it will have zero also, but total participation zero is not there. There must be some record.
So what you are saying in case of double line also, there is a provision of providing arrow and no arrow, right?
Yeah.
Arrow and no arrow, right?
Yeah. So if you see my tutorial on case study on your diagram, I have explained that same thing I have done there
I
also.
have gone through that, sir, but I think this point has not come. Like with total participation, whether it's a many to one or
No,
many
no,
to
it is
many. This
there. It is
Your
there on that.
tutorial case study.
It is there. Let me see.
tutorial means case study, right?
Yeah.
Yes, yes,
Case study on ER diagram.
yes.
That is there. Yeah.
Okay. So now what you are saying
Case
that in
study
case of
on ERB.
in case of double participation also. there is a provision of providing arrow or no arrow, right?
Uh, it depends on the condition, like what sort of problem given to you. So you can just
Hmm.
refer case study. I have used that part, I guess.
No, that's fine. Okay, sir. I
Total
will go through that
participation with
again.
menu to
I
one
will go through that
relationship.
again, sir. I'm just asking for clarification. Once again, I'm repeating my question that with total participation
Hello,
also, there is a provision of providing arrow or no arrow, right?
hello.
Sir, am I audible?
क्या net चला?
Am I audible, sir?
Okay.
Am I
Okay.
audible, sir?
Any other doubt? Anyone?
Sir, am I audible?
Huh.
Yes,
Okay.
Ganga.
Hello.
Yes, yes.
Hmm.
I think Piyush sir is not able to listen to me. Piyush sir, am I audible to you?
Yes.
So
Yes. You're audible. Yeah.
that's what I was repeating my
Yes, you're
question. Just
audible,
to,
GP. Yeah.
yeah, that's what I was repeating my question to reconfirm that with
Hello. Yes.
total.
Yes. You're audible. Go ahead. Yeah.
So I'm speaking, sir. I'm speaking.
I think Piyush says some like, can you rejoin?
No. Yes, I'm
I'm
audible. I'm
speaking.
audible to everyone, right?
Yes,
I
yes, yes, sir.
think
You are audible.
Ganga Prasad, you have some time lag. Give it a rest, and probably then he'll catch it up.
Uh,
Yeah, now you
yes,
talk.
to total participant also.
I think Ganga Prasad, now you try.
Yes. You can use. Yeah. Hello. Yes, Ganga Prasad. You
I have
can
put in
speak
chat
now.
box, sir. I have put in chat box, sir.
Actually, my net is not.
I have put in
I
chat
lost my
box, sir.
connection. Yes. We can do that. Yeah.
Okay, sir. Okay. Thank you, sir.
I will tell you the example also for that. You can refer to the case study. I have taken one example for that also.
Okay, sir.
Okay. Okay. Anyone? Any other doubt?
Yes, sir. So
No,
the
sir.
difficulty level of quiz will be similar to mock, or we can expect
Yeah, it will be
questions
same to activity. So not activity. Practice and graded question. Yeah, and
and
mock
the mock
also.
which you okay.
Yeah. Similar to that only. Okay then. Thank you everyone.
Okay, sir.
Thank you, sir. Thank you very much.
Thank you,
Okay.
everyone.
I will upload the recording on YouTube. Yeah.
Yes, sir.
Thank you.
Right.
Please do that.
Thank you, sir.
Thank you, sir.
Thank you, sir.
And all the best for quiz.
Thank you.